Picture this. You've got a startup that's just gaining traction. So you want to organize a database of customers and streamline some of your processes with updated programs. It wasn't too long ago that you'd have to keep all of your data and programs you want to run on premises, where your data is physically stored on site in a room full of massive computers. Thankfully, in the 1960s, some innovative engineers thought, hey, what if we shared computing power across a bunch of different businesses so they didn't all have to manage their own systems? The engineers' idea was a success then and continues to evolve today. Consider how far we've come. Today, instead of needing to find a physical space, staff, and surveillance, you can access the resources you need by connecting to a remote data center through the cloud. These remote data centers store awesome amounts of information, as well as hardware and software applications and networking equipment. Way more than those engineers dreamt. The cloud makes it all possible. I know, all this cloud stuff sounds fantastic. And it is. It's also extremely at risk of attack. Cybercriminals know that the cloud holds a ton of valuable data. That data is coming from users and industries all around the world. Cybercriminals also know the cloud is a complex, shared environment, so securing the cloud can be challenging. Cloud security is a vital and highly valued profession. It's also an exciting one, because as a cloud security team builds robust security, cybercriminals continue to attack. The content in this program will equip you with the knowledge and skills required of entry-level roles in the field of cloud cybersecurity. And career resources, including resume and interview prep, will help you prepare to apply for jobs in the field. My name is Megan, and I'm a security engineer at Google. I'll be your instructor for the first course of this certificate program. I'm on the security reviews team under Information Security Engineering. My team evaluates all of our product and feature launches to make sure they're secure before making them available to the public. I usually describe my job as ethical hacking. My background is in computer science, but I learned a lot about security in different ways. I took introductory security classes in school and learned about networking, disaster recovery, and offensive security through internships. Outside of school, I learned most of my hacking knowledge through online resources, cybersecurity certificates, like this one, and capture the flag challenges. A unique thing about me is that I'm disabled. I have a chronic illness that sometimes makes it difficult to work when I'm having a flare-up. I was worried about starting my first full-time job, but my coworkers and managers have been nothing but supportive. The program is divided into courses based on different cloud cybersecurity processes. The course topics include Introduction to Cybersecurity and Cloud Computing, Proven Strategies for Risk Management in the Cloud, Identifying and Protecting Against Threats in the Cloud, and Detecting, Responding, and Recovering from Cloud Cybersecurity Attacks. Each topic builds on the content before it, so I encourage you to complete the courses in order. The final course is the capstone. It's a great opportunity to demonstrate the knowledge and skills you gain throughout your academic journey. As you work on your project, we've got videos and readings to teach you cloud cybersecurity concepts and skills. Then, interactive activities and labs will let you practice those concepts and skills. You can take the labs more than once, and lots of learners do. So if you hit some trouble spots, just keep at it. You'll also have quizzes to confirm your understanding and glossaries to help reinforce key terms. I'll be by your side throughout this first course, making sure you're getting the foundational knowledge you need. Then, you'll meet my teammate Preston.
Hello, I'm Preston, and I'm a security engineer here at Google. Together, we'll explore cloud risk management frameworks. In this course, you'll learn how to identify risks and implement security controls to mitigate them. You'll also understand compliance while managing data protection and privacy, and you'll compare and adopt frameworks. Next, Manny will take over.
Hey there, I'm Manny, and I'm a Google security engineer. I'm really excited to introduce you to identity, management, and access control principles in a cloud environment. We'll check out 3 of my favorite topics: threat and vulnerability management, cloud-native principles, and data protection measures. Next, in the course on cybersecurity attacks in cloud, you'll learn from Celine.
Hi, my name is Celine, and I'm a security engineer at Google. I'm excited to investigate how cloud cybersecurity professionals can detect, respond, and recover from cybersecurity attacks. Together, we'll dive into logging, security and alert monitoring, and mitigation techniques. Last up, you'll meet Lewis, when you put everything together that you've learned in a capstone project.
Hello, I'm Lewis, a Google security architect, and I'm going to help you prepare to wow potential employers. Together, we'll put everything you learned from courses 1 through 4 into action in a capstone project. You'll create impressive work examples to share with future employers.
We instructors are really happy you're here. So let's get started. Hey there. Welcome to the first stage of your cloud cybersecurity learning journey. In this course, you'll explore essential security principles in cloud computing. You'll get an overview of the security lifecycle and investigate Google Cloud tools like the Google Cloud Console and Cloud Shell. You'll gain insight into DevSecOps, which stands for Development, Security, and Operations. This methodology integrates security into the entire software development lifecycle. Along the way, you'll discover how you can translate many of the skills you already have into the cloud security field. These transferable skills include problem solving, analytical thinking, collaboration, and communication. One of my favorite things about this field is that as the cloud evolves, so do the ways in which its security can be compromised, which means I get to learn new things all the time. So let's get started. In this section of the program, you'll kick off with a general introduction to cloud computing and cloud infrastructure. Then you'll examine how virtualization, containers, and storage function in cloud computing. Next, you'll deepen your defenses in the cloud using security controls, identity and access management, and networking practices. You'll also discover how users and cloud service providers share security responsibilities in different cloud models, like infrastructure, software, and platform as a service. Then you'll check out automation in the security lifecycle. You'll learn about teams and workflows, along with automation's role in software pipelines and infrastructure as code. Plus, you'll explore the software supply chain and the importance of securing it. To wrap up, you'll explore the roles, responsibilities, skills, and tools of a cloud cybersecurity analyst. You'll experience Google's Cloud Shell and add lots of tech solutions to your cloud security toolbox. I'm here to help you every step of the way. And keep in mind, you set the pace. When you're ready, head on over to the next topic. When you're learning a special skill, it helps to understand the basics first. You wouldn't try to surf big waves without knowing how to swim. That's why we're going to take a dive into the foundational concepts of cloud computing first, so you can gain the knowledge you'll need to succeed in this program and ride some waves into your future career. You'll start off with an overview of cloud infrastructure. Then you'll consider key strategies when migrating to the cloud. Next, you'll check out components of cloud computing and learn about how it improves on the traditional on-premises approach. Then you'll be introduced to containers and their applications in the cloud. You'll discover how containers help users deploy more agile and portable software packages. You'll also review cloud storage options for different data types. When you're ready, let's begin.
My name is Ben, and I'm the Senior Vice President of Learning and Sustainability at Google. I'd always been interested in learning because for me, my mother was a school teacher, and I felt that learning is really what enables people to reach a different point than they otherwise would. I know it enabled me to go to a place I could not have dreamt of being were it not for the education I got. And I think that's incredibly important for people to have access to that kind of opportunity. And growing up in India, I did have access to a good school. I did not come from a wealthy family, but I had access to a good school. And I saw the difference it made in my life. And I think today, with the help of technology, we can hopefully bring more of that opportunity to more people in the world. The cloud is really important because it's a trajectory of where computation is going. If you think about all of the major products that you use, almost all of them are now based in some online cloud data center. And they have access to all these amazing computing resources, and they enable you to these services to really provide amazing things for their users. So studying cloud technologies enables you to participate in that whole economy of jobs and of opportunities that consist of building these powerful facilities in the cloud that are being used by people around the world. One of the really interesting ways in which education is evolving is allowing people to build and learn individual skills through various skilling courses. Many aspects of education are not available to everybody everywhere, unfortunately. But it's possible to build the basic skills that one could get that one needs from an education more piecemeal today. And I think the approach of skilling can allow people to build up the pieces of the education that they really need in the way that they have access to, in the way that they have time for, in a way that they have the resources for. The initial parts of learning anything are learning the basics and the fundamentals. Whether it is a sport or a physical skill like carpentry or whatever, the first steps are learning the basics. So persevere with it, and it'll get really interesting. I've been working with computers for, what is it now, over 30, 35 years, and it is still fascinating every day.
Thanks to the cloud, we can now interact with data pretty much anywhere and at any time. Whether it's checking the weather to see if I need a sweater, or streaming my favorite podcast. It may seem like magic, but storing all that data and keeping it organized takes infrastructure. Of course, data existed and needed to be stored before the cloud. So let's check out where we started before learning where we're going. Before the cloud, organizations kept their data in large physical infrastructures, usually on-premises. On-premises, or on-prem as we say in the industry, describes information technology infrastructure that's physically located in an organization's own data center or office. This means the organization manages their own servers, networks, and storage to run and store data. Now the cloud uses these physical structures to run. All of the information it holds is hosted by a cloud service provider, also known as a CSP. And these providers store cloud resources in data centers. A data center is a physical building that stores servers, computer systems, and associated components, creating a centralized location for vast amounts of data. The servers within data centers provide computing power to the cloud. Cables connect the machines, which then link up to other data centers in the area. This is called a zone. A zone is the collective number of data centers in an area. A zone may contain one data center or multiple data centers. And a region is a group of zones. Google Cloud has many regions across the globe, and it's always growing. Google Cloud refers to the grouping of zones and regions as failure domains. A failure domain is a resource that can fail without impacting the availability of data. Failure domains can include zones and regions where data is replicated to improve resiliency. Resiliency is the ability to prepare for, respond to, and recover from disruptions. Having data across failure domains is one way that cloud service providers safeguard user data. Let's use an example. Let's say you're a cloud cybersecurity professional, and your organization uses cloud resources in a zone on the coast of Australia. You're in the middle of work one day when there's a power outage to the data center in your zone. It's all okay though. Your work is safe because you've selected services from your CSP that replicate your resources across other failure domains. The practice of having multiple copies of data in different locations to avoid a single point of failure is referred to as redundancy. Redundancy ensures your data is available when you need it. All right, now you know where data is kept in the cloud, but how is data stored? And more importantly, how fast can you access the stored data? With such an incredible amount of information being generated every single second, quick access is essential. This concept is called latency. Latency is the time it takes for data to travel from one location to another. This can be from a user's device to a cloud server or between cloud servers. For example, when you're on a website, the lower the latency, the faster the web page loads. And research shows that 53% of users will leave web pages that don't load within 3 seconds. I am definitely in that 53%, for the record. So, CSPs strive to provide low latency to users. Latency, redundancy, and the cloud's underlying infrastructure have the potential to significantly improve an organization's commitment to their users. In fact, these benefits contribute to an organization's digital transformation journey. Digital transformation is when an organization modernizes their applications, services, and customer relationships by using new technologies. The cloud's ability to scale and globally replicate data enables an organization to provide a better user experience to not only their employees, but also their customers. As a cloud security professional, it will be really important to understand how cloud infrastructure works. With your knowledge of these core cloud concepts, your cloud learning journey is underway. No latency here. The cloud delivers infrastructure in a few varieties called deployment models. Let's take a deep dive into the different options users have for tapping into the power of cloud computing. The deployment model is an important consideration for cloud infrastructure. There are 3 main options: public, private, and hybrid. First up is public cloud, which is a cloud model that delivers computing, storage, and network resources through the internet, allowing users to share on-demand resources based on their specific business needs and operational goals. So the CSP's infrastructure and resources are shared in a multi-tenant environment with other users. A multi-tenant environment is an environment in which cloud infrastructure and resources are shared among users. You never know who your data center neighbor might be. Even though you share resources, the other users can't access your data. Privacy matters. Next up is private cloud, which is a cloud model in which all cloud resources are dedicated to a single user or organization and are created, managed, and owned within on-premises data centers. In this cloud model, all cloud resources are dedicated to a single user or organization. They own the underlying infrastructure, typically in their own data center, but they use a CSP. Because the infrastructure and resources are dedicated to this single user, the private cloud is a single-tenant environment. A single-tenant environment is an environment in which cloud infrastructure and resources are dedicated to a single user. This model is especially useful for companies with compliance and/or regulatory considerations. Think of the private cloud as owning a business, and the public cloud as renting office space. An individual business is responsible for maintenance and repairs, but the business owner also has the flexibility to make renovations or structural changes, like adding a new kitchen. Similarly, using the private cloud means the business has both responsibility and control over the resources and infrastructure. On the other hand, when renting an office space, a business probably has to stick to the current floor plan and are unable to make structural changes. But the management company takes care of the upkeep and repairs, like the electrical, heat, and cooling. Your rent probably includes maintenance fees, but the business isn't responsible for the repairs. Much like the public cloud, users pay the CSP for both resource usage and maintenance. Okay, finally we have the hybrid cloud, which is a cloud model that combines public and private models, so organizations can enjoy both the cloud services and the control features of on-premises cloud models. Hybrid cloud allows users to add a public cloud provider to an existing on-premises infrastructure, which increases computing power without adding data center expenses. Because users choose where their applications sit and where computing happens, there are key security and compliance advantages too. A hybrid cloud is like having a storage unit. The business has the convenience and access of more space without needing to move or expand. With users consuming an increasing amount of cloud resources, the multi-cloud deployment model has emerged. Multi-cloud is the strategy of using more than one cloud service provider. For example, your organization might use Google's Gmail service for corporate email and another cloud service provider for storing its data. Whether your future employer is best suited to a public, private, hybrid, or even multi-cloud model, all offer innovative ways to advance and protect computing resources. All computer users, at one time or another, experience speed, performance, or storage problems. Maybe you bought a laptop, but it takes longer and longer to load because of limited space left on the hard drive. Or maybe your desktop computer has a lot of memory, but as it gets older, you can't add the app you want because the computer isn't compatible. Well, the cloud can help you with these and lots of other constraints related to storing your data, software, and hardware locally. And that's just what we're going to explore in this video. Specifically, we'll discuss 5 major cloud benefits. The first benefit of the cloud is faster time to market. With cloud computing, your organization won't waste time, energy, and money buying hardware, waiting for it to be installed and configured, and then inevitably diagnosing hardware problems. And the ability to quickly create infrastructure means getting new apps out to consumers much more quickly. The second benefit of cloud computing is scalability. In an on-premises environment, the number of storage devices varies with the demand for data. The cloud security team will need to add new devices in order to manage the growing data. When these devices are no longer needed, the team members have to find another use for the devices because they can't be returned to the supplier. But with the cloud, the resources automatically match the workload, often saving time, effort, and money. Now, just as time to market and scalability often lowers expenses, switching to the cloud itself can provide cost savings. When using an on-premises solution, a business is responsible for the costs of physical hardware, the staff managing the devices and data center, plus maintenance and service fees. This framework is called capital expenditure, or CapEx. The cloud follows an operational expenditure, or OpEx model. OpEx means you only pay for the resources you use. Pretty cool, huh? The CSP is responsible for all upfront costs of physical equipment and spaces, like servers, networking devices, and data centers. And because there are so many users, sharing cloud resources cuts the price tag for everyone. Okay, now there's the advantage of better collaboration. When using the cloud, companies don't need a direct connection to physical resources to access their data. With just an internet connection, they can access it from anywhere in the world. This enables globally distributed teams to collaborate easily and efficiently. Another prime advantage is the cloud's extensive security capabilities. And this, of course, is where cloud cybersecurity professionals really shine. They know how to ensure the confidentiality, integrity, and availability of cloud-based data, applications, and infrastructure. They work hard and think creatively to prevent unauthorized access or criminal exploitation. This keeps cloud assets safe and secure. Likewise, using the cloud helps avoid damage to business resources and information, and it prevents data loss because redundancy practices ensure information is replicated across failure domains. You might recall redundancy is the practice of distributing cloud resources across zones and regions. While there are lots of really great benefits to using the cloud, it isn't perfect. So it's important for cloud cybersecurity professionals to recognize the cloud's limitations. The reliance on a stable internet connection is of key importance. In some cases, a CSP's network connection might be compromised. This would cause users to experience longer wait times to access their cloud resources. The good news is that CSPs can mitigate this issue by having multiple connections to the internet for each cloud location. In a time when technology is developing at light speed, the cloud provides some key advantages that enable organizations to make the most of these incredible innovations. As a cloud security professional, you'll play a key role in helping your future employer advance its operations, quickly scale, adapt to market changes, minimize costs, and increase data security. These are just some of the ways you can bring a ton of value to any organization you serve. You might know that phrase, the only thing constant is change. This idea of change is directly relevant to cloud technology, especially its ability to constantly keep up with amazing technical advancements, surprising market shifts, ever-evolving consumer demands, changing organizational structure, and so much more. The pace of change is accelerating, so it's important to be able to adapt. This can be challenging, but it's also an opportunity to grow and learn, just like you're growing and learning through this training. By embracing change, you're in a better position to stay ahead of the curve and make the most of whatever may come your way. And what's coming your way in this video is an investigation into cloud computing and how it enables businesses to proactively respond to change. Let's start with a quick definition. Cloud computing refers to the practice of using on-demand computing resources as services hosted over the internet. For example, this enables users to reduce information technology, or IT, overhead while enjoying advantages like scalability, enhanced collaboration, responsiveness, and cost savings. In cloud computing, an instance is a server resource that runs workloads in the cloud. Instances are created or retired quickly to keep pace with the latest releases and updates. Now, a very important part of cloud computing is something called ephemerality. Ephemerality is the concept that things only exist for a short amount of time. In other words, change in the cloud is constant. Cloud security analysts use ephemerality on the job all the time. Take this example. Rather than spending time patching software on enduring physical servers, analysts create a new server image, which is a server in the cloud. Creating a new, healthy server means analysts can quickly launch a new instance. Ephemerality helps make the cloud more flexible because resources can easily adapt to change. The CSP enhances the performance of cloud assets, since assets can scale quickly using ephemerality. Ephemeral resources are a big plus in the security field because they are less likely to be targeted by attackers. Cybercriminals would need to quickly find and exploit a vulnerability before it's destroyed. All right, now let's go over the three main categories of cloud computing resources: compute, storage, and networks. In the cloud, compute refers to computation performed by a physical computer in a remote environment. For example, memory, CPU, and storage are all compute components. Basically, compute is the brainpower behind running resources. All of these compute elements run on remote servers, so organizations don't need to worry about managing or providing physical equipment. Organizations can efficiently scale the volume of their data up and down. Let's take an example. Consider a clothing company that offers discounts to online purchases of winter jackets in the spring season. In the past, its website experienced lags and downtime because of the increased traffic. This frustrated customers and negatively affected sales. In response, this retailer opted to migrate to cloud computing. And next spring, the website's workload automatically scaled to meet increased demand. Customers appreciated browsing and checking out quickly, thanks to the cloud's low latency. Then, once the peak season was over, the company's compute resources scaled back to normal workload levels. Good for the customer, good for the business. Okay, next up is storage. Cloud data storage is a solution that enables organizations to keep, access, and maintain digital data on off-site cloud-based storage devices. So just like compute, the CSP uses a remote infrastructure when storing data. Finally, networks in the cloud run using software. Unlike traditional networks that require physical devices, software enables users to change their network designs without buying new hardware. And using a cloud network provides visibility into the communication between your incoming and outgoing network traffic. With cloud computing's compute, storage, and network capabilities, managing workloads is an efficient process. Better yet, from exciting new inventions to sudden disruption and everything in between, the cloud makes it possible to react to change with confidence. Now, I hope that you are also becoming more confident with your knowledge of the cloud. Welcome, Future Security Pro. Thanks for joining me for this video all about virtualization and virtual machines. Virtualization is the foundation of cloud computing. As a cloud security analyst, it's going to be super important for you to understand how it works. So let's dive in. Virtualization is a technology that creates a virtual version of physical infrastructure, such as servers, storage, and networks. This technology uses virtual machines, or VMs, to simulate a physical computer. VMs contain their own operating systems, like Windows and Linux, and use only a portion of the underlying computer's compute power. Virtualization uses hypervisors to manage the relationship between physical and virtual resources. A hypervisor is the abstraction layer that sits between the physical computer and the VM. Abstraction is what separates hardware from software. There are two types of hypervisors. Type 1, also known as bare metal. Type 1 is more common. It replaces the entire operating system of the underlying computer. Type 1 hypervisors interact with the operating system's components directly. Having this direct access makes Type 1 streamlined and secure. On the flip side, Type 2 hypervisors, also known as hosted, use the computer's existing operating system and runs as an application over the operating system. Type 2 hypervisors may be easier to install, but you need to take into consideration the extra overhead and security needs of the underlying operating system. So, hypervisors distribute resources across VMs and keep VMs separate so that each one simulates an individual computer. And the hypervisor ensures that information in one VM is not visible to others. In this way, an organization's development team can transform one physical computer into lots of virtual machines, instead of buying new hardware each time they need a server. If needed, a development team can also add CPU, memory, and storage space to the VM. Now, let's discuss the three advantages of VMs: portability, scalability, and testing environments. The first advantage, portability, makes VMs especially useful for hybrid cloud environments where application resources are shared between on-premises and cloud infrastructure. Because each one is an isolated entity, developers can relocate them throughout a network. The second advantage, scalability, means that VMs can be scaled to provide additional or fewer resources if the development team's needs change over time. This is unlike physical servers, which have a fixed amount of hardware. The third advantage, testing environments, help developers test code without worrying about affecting existing infrastructure or users. Plus, VMs simplify testing because developers don't need to deploy complex production environments, and they can delete the testing environment machines afterward. As a core foundation of cloud technology, virtualization will be a big part of your future career in the cloud. You'll be a major asset to any employer because you understand the advantages virtualization offers and you can maximize its power. Think about how a package delivered to your door got there from its original location. It probably started off in a warehouse and then went inside a cargo container. There'll be many packages of different sizes inside each container. Next, the containers are loaded onto a transport vehicle, like a train car or ship. Multiply this by thousands of containers over the world. They're transported from one place to another, but this doesn't change the contents inside, like your package. Okay, so a container is a software package that holds only the components necessary to execute a particular application. Each container has a container image, which is a file with the code and dependencies that the container requires to run the application, like documents in a filing cabinet. The cabinet is the container. The folders in each drawer are container images, and those container images store the documents or information needed to perform a task. Developers use something called container registries to upload and download container images. This enables teams to share and deploy consistent images, and organizations use orchestration tools to help deploy, scale, manage, and monitor containers. Packaging software in a container uses less memory and fewer resources because the operating system itself is not included in the container. And bonus, they're isolated from the surrounding environment, which means they're pretty easy to deploy across cloud deployment models, like public, private, or hybrid clouds. You'll work with containers a whole lot throughout your career, so it's important to understand their key benefits, including portability, immutability, and responsibility separation. Let's kick off with portability. Containers enable users to run software quickly from one computing environment to another. This portability helps create cloud tools super efficiently. Unlike virtual machines that have an operating system, containers only house isolated software while using a common underlying operating system. This allows an individual container image to run in multiple locations without the need for a separate operating system. All of this contributes to their portability. Next up, immutability. Immutability means an object can't be changed after it's created and assigned a value. Just like the contents of those shipping containers don't change during transit, cloud containers also can't be modified during their lifetimes. If a container does require a change, users must create a new container image and redeploy it. This also allows developers to seamlessly replace outdated or insecure container images. Immutability makes containers more secure by ensuring consistency across multiple deployments, since there is no patching or updating that could cause configuration drifts. Lastly, containers separate the responsibilities among the developers and operations teams. Developers can devote their time to managing the container's code, and operations teams can concentrate on deploying and managing the container's applications. This frees people up to work on the projects where they can bring the most value. And there's nothing like knowing you're playing to your strengths. Guiding you through this lesson was a blast. I can hardly contain myself. Okay. But seriously, I'm confident that you'll bring all kinds of value to your future security team and organization, especially because you'll be able to clearly and confidently advise them about all things containers. There's all kinds of different storage out there for our important documents, data, and more, like hard drives, and even your smartphone. These devices are great for personal use, but what if you need to store assets for thousands of users? Well, enter cloud data storage. The cloud makes it possible for organizations to store truly massive amounts of data. And that's what we're going to explore in this video. Cloud data storage is a solution that enables organizations to keep, access, and maintain digital data on off-site cloud-based storage devices. A cloud service provider, or CSP, is responsible for ensuring the replication and availability of the data, and users can retrieve their data using the internet anytime from anywhere. Before cloud data storage, organizations kept data locally in on-premises computers or servers. As companies grew, more storage was needed to accommodate the increasing volume of data. Businesses started adding more servers, external hard drives, and larger storage systems to meet this increasing demand. But cloud data storage addresses lots of the challenges associated with traditional methods. Plus, users benefit from scalability, redundancy, cost savings, and security. Let's take a deeper dive here. First, storage using the cloud allows for scalability. When an organization needs to store more data, they can adjust their use of the cloud accordingly, without the need to buy, install, organize, and manage new physical devices. Another benefit is redundancy. Redundancy is the practice of distributing cloud resources across zones and regions. This means the CSP duplicates the user data across multiple failure domains, making sure the data is safe and always available. So, if a component fails, the redundant backup can take over, allowing the user to have access to the data. A third benefit is cost savings. With cloud data storage, users no longer have to buy and maintain their own devices. It's the CSP's responsibility to have the infrastructure to host and maintain the data. They also provide high levels of uptime, so that the data is available whenever the user needs it. Because users no longer pay upfront costs, the overall cost of the data storage goes down too. Plus, users only pay for storage resources they use. And because of the ability to scale, it's not necessary to pre-buy storage in case a company suddenly needs more storage capacity than expected. Cloud data storage also offers important security controls to check user authentication, access control, and data encryption. The scalable, redundant, cost-effective, and secure aspects of cloud data storage provide a more seamless experience when managing data. This has become a key solution for companies of all kinds. It's helpful for small businesses or entrepreneurs who might not have the resources to handle vast amounts of data. And of course, larger companies also leverage the cloud's ability to store and move massive amounts of data quickly and securely. Understanding cloud data storage is an essential foundation for your data security career. It offers a number of business benefits, and your know-how will help any employer make informed decisions about how to put cloud storage to excellent use. Deciding where to store something has everything to do with what's being stored. Here's an example. Let's say you just made some iced tea. You'd most likely put it inside a liquid container with a tight-fitting lid, not a flimsy paper takeout box. Or let's say you went to the store and bought a 12-pack of paper towels. You wouldn't keep them all on your kitchen counter. You'd probably put one roll in a dispenser, then store the rest in your pantry until you need them, right? There are lots of different ways to store and use data in the cloud. And just like the liquid iced tea and the bulky paper towels, there are many storage options available in the cloud. Let's cover the different types of data being stored. This is important to understand because each storage type contains a specific data type. First up is structured data, which is data organized in a certain format, like rows and columns. It's taken from its native form and transformed into a predefined format. A predefined format means that all submitted data are categorized into specific fields. The data is then stored in a database meant for storing structured data. This makes structured data easy to search. Examples of structured data include names, addresses, credit card numbers, and dates. Next, unstructured data is data that is not organized in any easily identifiable way. It's stored in its native form and appears in a variety of formats, including images, videos, and documents. These formats aren't structured at all. For example, think of a doc file. It can contain text, images, or even embedded photos and videos. These data types are unstructured because they can't fit in the tables and rows of a database, like with structured data. Luckily, there are specific types of storage to accommodate all types of data. Let's take a rundown of the three main storage types: file, object, and block. To start, let's examine file storage. File storage uses a hierarchy of files in folders. It keeps data in one place and organizes it in a simple, easy-to-understand way. File storage is ideal for smaller volumes of data that a few people might need access to, like files on a family computer. Each file starts at the home directory. Then users can navigate to what they need by following a logical path. File storage is the oldest and most widely used data storage system, but it has some limitations and can only handle so much. File storage is also commonly used in data repositories. Developers rely on repositories as a centralized place to store, download, and share data. All right, let's move on to object storage. Object storage holds unstructured data in something called a bucket. A bucket is a virtual container that holds objects. Each bucket is assigned a unique name. These buckets can be public, meaning that anyone can access the objects inside, or private, so only certain people have access. Using buckets is a great way to organize large amounts of unstructured data. When storing data in block storage format on the cloud, data is split into smaller blocks, each stored in different locations to maximize efficiency. Each block is given a unique ID, and when users ask to retrieve their data, the smaller blocks are connected together again based on these IDs. Block storage is flexible and efficient, as it can be accessed by any operating system and any virtual machine system. Great work learning all about data types and storage options. With this information, you now know how to use the cloud to properly store data. This brings you one step closer to protecting information in the cloud. Bye for now. Congratulations on completing the first section in your Introduction to Cloud Computing. In this section, you learned some essential cloud computing concepts, which you'll build on throughout your journey to becoming a cloud security professional. You started with an introduction to cloud infrastructure. This included understanding its distinctions from on-premises methods and key considerations of moving to the cloud. Then you explored what the cloud is made up of by learning the components of cloud computing. Next, you learned about containers in the cloud. You also explored several advantages that containers bring to organizations. This section wrapped up by discussing the different storage options that are available on the cloud, including file, block, and object. Thanks so much for being here with me, and keep up the amazing work. Hey there! Ready to explore security principles in the cloud? There's so many exciting things in store, and I can't wait to go on this journey with you. Together, we'll examine the different layers of security and explore how each layer applies to the cloud. We'll also go over different security measures used in cloud environments. First, we'll explore security controls used in cloud computing. Then we'll discuss how the defense-in-depth approach applies to securing cloud resources. Next, we'll go over security responsibilities you'll share with cloud service providers, CSPs. You'll also learn about the shared responsibility and shared fate models, and the considerations of sharing security with a CSP. Then you'll build on shared responsibility concepts by learning about different cloud service models. You'll also review how infrastructure, platform, and software as a service offer varying degrees of security responsibilities. After that, you'll examine how identity and access management helps you maintain control over your resources. You'll also be introduced to the principle of least privilege and separation of duties in identity and access management. Finally, we'll discuss networking in the cloud. This includes software-defined networking, virtual private clouds, and load balancing. You're about to learn some really cool ways to secure cloud environments using security principles. I'm excited to go on this adventure with you. When you're ready, let's get started. Just like you might help someone you care about cross a busy street, in the world of cybersecurity, different strategies are used to protect data and assets, especially sensitive ones. The more valuable an asset is, the more advanced the security protecting it should be. Today, you'll learn about a strategy that's used to protect critical assets, the defense-in-depth model. Using this model can help protect cloud resources. It can also improve an organization's ability to manage its defense of assets and data, which is an organization's security posture. Defense-in-depth is a layered approach to vulnerability management that reduces risk. Defense-in-depth uses multiple security controls to protect assets. Let's learn about some of the cloud security controls that can improve your defenses. As a cloud security analyst, there are several security controls you'll encounter in your day-to-day tasks. Security controls are safeguards that reduce security risks. Common types of controls used in the cloud include identity, protective, network, detective, responsive, and recovery. The first type of control we'll cover are identity controls. An identity control is a measure that helps authenticate a user before they access resources, like networks or storage. Identity controls are becoming a lot more common, so it's possible you've encountered them before. One of the most common examples of an identity control is when your email provider asks you to add another email or phone number to verify your identity. This is an example of an identity control known as multi-factor authentication, which adds an additional layer of security to the authentication process. Another type of security control is protective controls. A protective control is a measure that protects access to resources and shields against malicious attacks. Other examples of protective controls are installing antivirus software on individual VMs, web application firewalls, and organization and infrastructure as code policies. A network control, like a firewall, is a measure that helps protect access through network paths. Next, a detective control is a measure used to identify suspicious activity if it occurs. An example of a detective control is an intrusion detection system that monitors system activity and alerts analysts if there's a possible intruder. Google Cloud Security Command Center is an example of an intrusion detection system that can alert cloud security professionals of malicious activity. A responsive control is an application or tool that uses automation to respond to security events. For example, responsive controls could automatically notify you through email or other systems in response to a detected threat. Finally, after detecting and responding to threats, analysts use recovery controls. A recovery control is a measure that restores access and functionality in the event of failures. The most common example of a recovery control is where you can revert to a backup of a system you stored after an attack. The combination of these controls create a more robust defense strategy for your organization. Think of the controls working together like a security system for a community garden. Gotta keep those prize-winning tomatoes safe. Identity controls determine who is able to access the garden, and installing a fence around the garden's perimeter acts as a protective control. You protect access to the garden by only giving authorized people a key to the gate, like using network controls. Using a detective control, you install a camera to monitor suspicious activity. Then, if there's suspicious activity, you'll use a responsive control to receive an automatic text message. Last, using a recovery control, you can re-establish the security of the garden by mending any failures in the fence. Now that you're familiar with the different layers to secure assets, you can combine them to create a defense in-depth security strategy. By adding security controls in each layer, you can increase the overall security of your cloud resources, making this an effective strategy to reduce your vulnerabilities. The cloud offers many capabilities for securing resources. This gives security professionals the exciting opportunity to protect assets in a variety of ways. In this video, you'll learn about the shared responsibility model and how customers and cloud service providers, or CSPs, work together to protect the cloud and a business's assets. A customer is an organization or user who pays a cloud service provider to host and run their cloud resources. Before diving deeper into shared responsibility, let's examine the difference between on-premise and cloud responsibilities. In a traditional on-premises model, a business owns their own data center and servers. The business is responsible for securing their services against threats. However, if that business decides to use a CSP to run or store their resources in the cloud, then the CSP takes responsibility for some of the security of those assets. The amount of CSP involvement depends on several factors. Let's explore these responsibilities further. The shared responsibility model is the implicit and explicit agreement between the customer and the cloud service provider, or CSP, regarding the shared accountability for security controls. In the shared responsibility model, the CSP is like a gymnasium. The gym provides the building and equipment and ensures the equipment works properly. The customer is responsible for using the equipment safely and maintaining their own personal fitness goals. Before the customer starts using the gym, they sign a contract where they agree to use the equipment appropriately. Shared responsibility works in a similar way, where the customer and CSP agree on who is responsible for securing what resources. One way to think about shared responsibility is considering security of the cloud versus security in the cloud. Here are some common CSP responsibilities. The CSP must maintain physical infrastructure like servers and data centers. Additionally, CSPs need to ensure network and resource availability. These responsibilities provide the security of the cloud. The customer is responsible for configuring their services to meet their specific security and compliance requirements. The customer is also responsible for securing their data. Organizations have to consider the security requirements of the people using their apps and resources. In these cases, the focus is to secure data in the cloud. For example, imagine a customer uses a CSP's network and wants to incorporate network controls. The CSP provides the network and firewall service and is responsible for their maintenance and updates. The customer is responsible for configuring the firewall, monitoring traffic, and responding to incidents. CSPs usually provide each customer with a service level agreement, or SLA, that quantifies the availability of services. For example, A service may offer an SLA of 99.99%, where that service must be accessible and available for the user 99.99% of the time. In the network example, the SLA outlines the customer's terms for network controls, which eliminates guesswork for who is responsible for what. Although the customer and CSP are securing different aspects of the network, both parties work together to achieve better security. The customer's workload and level of service, meaning infrastructure, platform, or software as a service, dictates how much responsibility the CSP assumes. The more the CSP manages, the more they are accountable for security. Responsibility levels also vary by industry type and regulatory frameworks. Within these frameworks, the customer should know the security controls they're responsible for, what controls the CSP provides, and default inherited controls. Inherited security controls demonstrate security posture to auditors. The proper use of security controls is important, especially if a business must comply with specific regulations or other government and industry requirements. A business's location also impacts how they apply shared responsibility. Different countries may have different types of regulations and requirements for their data. In this video, you learned that implementing shared responsibility can come in many different forms. CSP customers have lots to consider, including the type of workload, industry, and location. Understanding how to manage these considerations will create a strong relationship with a CSP. The shared responsibility model has lots of benefits, but sharing security responsibilities also creates a new set of challenges. Learning to identify and navigate these challenges will improve your effectiveness as a cloud security professional. The first and most common challenge is misconfiguration. Misconfiguration is a leading cause of security breaches in the cloud space. Cloud technology is constantly evolving, and managing the frequency of updates and new integrations is difficult for a lot of organizations. Misconfigurations sometimes happen because of inadequate security during development. Insufficient security makes it easier for malicious actors to infiltrate systems and source code repositories. More importantly, misconfiguration can leave data exposed, which can result in major regulatory fines for an organization. As a cloud security professional, you can help a business avoid these types of security vulnerabilities by closely monitoring resource provisioning and incorporating automation and safe security policies. Another measure that you can use to prevent misconfiguration includes properly managing identity and access management, or IAM policies, and using the principle of least privilege. The principle of least privilege means that a security architecture grants the minimum authorizations needed for a principal to perform its function, which in turn reduces risks. Suppose you need to unlock a door in a building. The principle of least privilege means that you would have a key that only unlocks that door, rather than a key that unlocks every door in the building. Next, larger companies usually use a variety of services to host and manage their cloud resources. Companies must consider the different services CSPs offer and how these services relate to one another. Vulnerabilities in security may arise if the business and the CSP don't closely monitor services when sharing responsibility. Another shared responsibility challenge you might come across involves tracking how regulations change as your company and market grow. The company you work for might acquire other companies or expand its product line, both of which could change the security landscape, the controls needed, and the established service level agreements with their CSP. Consider this scenario. A business acquires a small tech company based in a different country. The business must now assume responsibility for the tech company's data as a result of the acquisition. Companies within a given country have to consider and comply with other countries' guidelines. Finally, remember that security is an ongoing process. It's important for your security team to stay up to date with the latest threats and vulnerabilities that may harm the business. In this video, you learned about challenges organizations might face when they work in a shared responsibility model. A better understanding of shared responsibilities implications can help customers make informed decisions about their security practices. Let's pretend you've been assigned a school project with a partner. Naturally, you want to do well on the project, and you hope your partner does too, right? You want them to work just as hard as you so you can share the work fairly and get the best grade possible. Things work similarly in the world of cloud security. As organizations make the decision to migrate to the cloud, one of the factors they have to consider is the trust they have in their cloud service provider to secure their data and resources. This trust is one of the main reasons for the shared responsibility model with a CSP, which has recently been elevated to a model known as shared fate. The shared fate model emphasizes the CSP's involvement in the customer's entire security journey and offers resources to securely manage their environment at each stage. The shared fate model was created to respond to gaps in the shared responsibility model, with the CSP offering more extensive guidance in how to secure customers' cloud-based resources. This addresses the challenges that customers face when using the shared responsibility model. Some of these challenges include navigating changing regulations, determining how security controls overlap, and approaching security as an ongoing process. The primary purpose of the shared fate model is to increase the level of trust between the users of cloud services and the cloud service provider. In shared fate, the cloud service provider invests more time to develop resources to help the customer design, deploy, and operate their cloud environment. This means there's a stronger partnership between the customer and the cloud service provider. There are several ways the shared fate model can increase the level of trust with the customer. 3 examples we'll cover are security foundations for users, landing zones, and mitigating risk. Security foundations for users are used by Google Cloud. Google's security foundations are a list of best practices, or blueprints, for configuring and deploying Google services. They deploy and maintain secure solutions using infrastructure as code. The second way the shared fate model increases trust is with landing zones. A landing zone is a modular and scalable configuration that enables organizations to adopt Google Cloud for their business needs. Google offers guidance on configuring landing zones. For a user that's new to the cloud, using a landing zone provides a starting point for adding identity provisioning, a resource hierarchy, and network and security controls. Finally, the shared fate model focuses on mitigating risks with the Risk Protection Program. Part of the program includes Google's tool, Risk Manager. Risk Manager is a Google Cloud security tool that offers insight into your organization's technical risk posture. It lets you generate reports to evaluate risk across your organization. Throughout this video, you learned about how the shared fate model strengthens the relationship between customers and the CSP, and how it distinguishes itself from the shared responsibility model. Building trust and understanding common vulnerabilities are huge assets to security analysts. Imagine you work for a nonprofit organization. Your boss schedules a meeting to explain that the organization is migrating some resources to the cloud in an effort to save money. As the nonprofit security analyst, it's your job to decide which cloud service model is the best fit for your organization's security needs. To help you make that decision, let's examine some of the most widely used service models. Cloud computing has several service models available depending on the degree of service customers need. The 3 major models include Infrastructure as a Service, or IaaS, Platform as a Service, or PaaS, and Software as a Service, or SaaS. The type of workload determines the level of responsibility the CSP has over your organization's security and resources. The CSP has the least responsibility in the IaaS model. In IaaS, the CSP provides instant access to infrastructure services, ranging from compute, storage, and networking to virtualization. The customer manages all other services, like virtual machines, operating systems, data, and security. With IaaS, the customer doesn't have to worry about maintaining their own data center infrastructure. Next, in a PaaS model, the CSP supplies and manages the hardware and software resources needed to develop applications. Customers write the code and manage all the apps, data, and security, while the CSP is responsible for maintaining the software development platform. PaaS manages more resources than the IaaS model, so IT and development teams have less operational responsibilities. Lastly, the CSP has the most responsibility in a SaaS model, where customers only need to focus on securing their content and access policies. So customers pay for web applications accessed over a network connection. SaaS is widely used in cases where companies don't have the staff or resources to build their own applications. Google's Gmail offering is an example of a SaaS environment. Gmail users control the data on the email platform, while Google provides the software and the hardware. All of these models share one thing in common. The customer is always responsible for securing their data. There are several service models beyond IaaS, SaaS, and PaaS. For example, Functions as a Service, or FaaS, provides serverless computing to developers who want to run singular pieces of code. Serverless computing separates physical servers from development environments. Developers use this service when they don't want to manage back-end infrastructure like servers or resources like containers. Identity as a Service, or IDaaS, is another cloud service model. IDaaS is commonly used for multi-factor authentication, single sign-on, and identity and access management. Implementing IDaaS is one measure to prevent threat actors from gaining unauthorized access to your data. Lastly, Firewall as a Service helps organizations create more secure networks. Firewall as a Service is useful for growing organizations that need firewalls to block unauthorized access. As the volume of employees and their connected devices increase, so does the need for firewalls to protect the organization's resources and network. Let's come back to the nonprofit scenario. Your overview of the cloud service models helps you make a decision about the best model for your organization. You narrow your search down to the IaaS, PaaS, and SaaS models because they all remove the need for maintaining your organization's infrastructure. PaaS is useful for your developers so they can focus more on writing code and less on the actual platform. And with SaaS, your organization only needs to secure your data and access policies. When you consider the strengths of each service model, you decide IaaS is the best fit for the nonprofit. Using the cloud's infrastructure means you'll spend less time managing physical resources, and you'll still maintain control over a lot of your services, like your operating systems and data. With the information you learned about cloud service models, you are better equipped to choose the best model to meet your organization's needs. Let's consider a scenario where you're a member of the cloud security team at a local university. The university is preparing to migrate their traditional on-premises infrastructure to the cloud. You're tasked with reporting how infrastructure as a service, IaaS, is beneficial to the university's needs. In this video, you'll discover what IaaS can offer you in the world of cloud computing. IaaS is a cloud computing model where the CSP provides on-demand access to computing resources such as servers, storage, networking, and virtualization. IaaS offers lots of benefits for organizations. First, IaaS is scalable, so customers can configure their resources to increase and decrease on demand depending on their needs. In the university example, IaaS's scalability improves resource allocation. For example, during peak times of the school year, like student enrollment or final exams, the college's IT infrastructure expands to accommodate the increased workload. When students leave campus during winter or summer break, the infrastructure scales back to adjust to the decreased workload. Second, in an IaaS model, the CSP pays for the underlying equipment and devices. The customer only pays for the resources they use. Continuing with the scenario, the university can use any savings that comes from adopting the cloud for other budgetary needs. Additionally, removing the need for physical servers and equipment opens more space for students. Third, adopting IaaS improves business productivity. With the CSP managing the physical infrastructure, IT teams can devote more time to managing infrastructure services and security. While the CSP secures the underlying infrastructure, the bulk of the security responsibilities belongs to the customer. Just to name a few, responsibilities include securing data, operations, and access and authentication. With this understanding of IaaS, you might wonder how exactly workloads are transferred to a cloud platform. One way to move your infrastructure from an on-premises environment to the cloud is by using the lift and shift migration model. Lift and shift is a migration model where workloads are moved to the cloud with little to no modifications. Because this model requires fewer modifications, it doesn't take long to migrate your workloads or for teams to adjust to using the cloud as a platform. Adopting IaaS is beneficial for organizations looking to migrate to the cloud while maintaining the most control over their workloads. After considering the advantages of IaaS and how to migrate your resources, you can provide the university's security team with a well-informed perspective. This type of knowledge can help you make confident, informed decisions in real workplace situations. Imagine you're on the cloud cybersecurity team of a small tech company. As the business grows, you investigate software as a service, SaaS, as an option to help manage your workloads. Let's review what SaaS offers to better understand what this service can do for the company. SaaS is a cloud-hosted application software accessed over the internet through a web browser or mobile app. The SaaS model is ideal for organizations who might not have the staff or expertise to manage infrastructure or build their own applications. Customer responsibilities include securing their data and access policies. That's it. Gmail is an example of a SaaS product. Google manages the Gmail application and all of the underlying infrastructure. Gmail users manage their emails and login access. Most SaaS offerings operate using a subscription model. If more or less capacity is needed, customers can purchase a different tier that will adjust to the workload. For example, if Gmail users have large amounts of saved emails with attachments, they may want to upgrade to a tier with more storage. With the CSP managing and maintaining the infrastructure, operating systems, and storage, CSP customers have far less overhead. Overhead is the use of excessive hardware or personnel resources to accomplish a task. Organizations adopting SaaS only pay for using the software, so customers don't have to worry about paying for and maintaining the equipment and servers needed to support the workloads. One advantageous aspect of SaaS is the instant use of apps. Customers can access most SaaS applications online on a web browser, which eliminates the need to download software. So SaaS applications are globally available. For example, you can access software for work while traveling or retrieve photos from the cloud. The SaaS service model has much to offer, but there are also considerations organizations should take when using SaaS. One of the biggest things to consider is shadow IT. Shadow IT tends to occur when employees or teams use SaaS products without getting approval from IT teams first. This practice is a concern for IT staff because those products might be inadequately secured, leading to more vulnerabilities and security issues for the organization. To summarize what we covered in this video, SaaS is ideal for those searching for a solution that requires minimal maintenance and security responsibilities. Now that's downright practical. It's important to know who has access to what. In security, making sure the appropriate people can, or can't, access certain things is essential to maintaining strong security measures. In this video, we'll explore identity and access management, or IAM. Let's cover some key parts of IAM: roles, principles, and policies. Roles are a collection of permissions that can be applied to principles. Permissions determine the actions a principal can take, and principles represent either an end user or an application. Principles can take several forms, like a Google account for end users, or service accounts for workloads and applications. A service account is a non-human identity that is typically granted to virtual machines, applications, and services. They're granted IAM roles to perform certain actions. Principals are assigned a role that grants permissions, rules, policies, or constraints. Depending on these role assignments, principals are then granted access to their organization's applications and resources. So to recap, roles are a way to organize the permissions of each principal. Granting a role to a principal transfers all the role's permissions. For example, a person on your team might need to access a storage bucket. To get access to the bucket's content, they would first need to be granted the correct role. When granting roles, it's important to apply the least amount of privileges. Only grant a user or principal enough access to perform their job. Categorizing principals as end users or service accounts is helpful. But what if you work for a company with hundreds of users? Groups are a solution to combining principals. Organizations can use groups to combine users or service accounts together to more easily assign access controls for larger sets of accounts, instead of assigning individual access one by one. Next, we'll go over policies. Organizations can set allow or deny policies that attach roles or deny permissions to resources. An allow policy is a type of access a principal has and sets conditions on this access. A deny policy is a constraint that sets rules to prevent principals from carrying out certain actions. It's an IAM best practice to create an allow policy for groups instead of multiple individual accounts. For example, an engineering team might consist of 50 people, Instead of setting a policy for each individual person, it's more efficient to create a group for the team members, then use an allow policy to bind the group to a role that has the permissions needed to perform their job. In this video, you learned about several key parts of IAM. With an understanding of roles, principles, and policies, you'll be better equipped to secure your resources. Making sure the right people have the appropriate access permissions will allow you to keep data and assets secure. When you think of networking, you might think of making connections with others in your work industry or social interest group, like a book club. In cloud security, you might think of connecting to online resources. But there's so many more aspects. And because networking is a huge part of cybersecurity, lots of companies are turning to the cloud for networking services. In this video, we'll uncover how traditional networking concepts translate to the cloud. Traditional networking infrastructure uses hardware and devices, like routers and switches. Remember that a router is a network device that connects multiple networks together. A switch is a device that makes connections between specific devices on a network by sending and receiving data. With networking in the cloud, instead of configuring hardware routers and switches, as a cloud cybersecurity professional, you implement routers and switches using software. This process is called software-defined networking, or SDN. CSPs use SDN for cloud services, where the routers and switches are hosted in data centers. SDN virtualizes these network devices, meaning the networking components are abstracted from the physical devices powering the network. You can configure SDN through either their cloud provider's console or by using an application programming interface, or API. An API is a library function or system access point with well-defined syntax and code that communicates with other applications and third parties. So instead of buying a hardware router, you can define a router in the cloud by calling an API. The API then requests access to the router for the organization. SDN is useful because it reduces the amount of maintenance an organization needs to keep networks running. The CSP manages the physical devices, so you can focus on developing and securing their applications. SDN is also scalable. You can add or subtract networking resources on demand as you need them. SDN also incorporates network monitoring, which can be used to detect distributed threats like denial of service attacks and unauthorized network scans. This security capability makes SDN valuable for cloud security teams. Along with these advantages, the cloud uses load balancing to distribute traffic. Load balancing distributes user traffic across several cloud servers, where the load balancer moves traffic to the appropriate backend service, like the cloud resources running your application. Distributing traffic prevents one server from becoming overwhelmed with traffic, which leads to slow performance. Load balancers also help ensure high availability for your resources. There are two types of load balancers: application and network. Both load balancers operate at different layers of the Open Systems Interconnection, OSI, model. The OSI model is a standardized concept that describes the 7 layers computers use to communicate and send data over the network. Security professionals use this model to communicate and pinpoint security threats when they occur. Application load balancers use one IP address to run workloads. They operate on layer 7, or the application layer, for HTTP or HTTPS traffic. The application layer connects users to the internet using software applications. When you access a website during peak shopping seasons, the application load balancer is what gets you and hundreds of other users to the web page quickly. Network load balancers operate on layer 4 of the OSI model, the transport layer. This layer is responsible for the delivery and speed of data between devices. The network load balancer handles traffic from UDP and Transmission Control Protocol, or TCP. This means the load balancer takes information from a router and forwards it to the correct TCP or UDP server. You just learned a lot about networking in the cloud, including the parts and benefits of SDN and load balancing. Networking is a major component of cybersecurity and cloud computing, so this knowledge will help you along your cloud journey. And as a cloud security professional, it'll be important for you to understand how traditional networking concepts translate to the cloud. Imagine you're hungry. So you decide to go to your favorite restaurant. When you walk in, the restaurant is crowded with people, and all the tables are full. Thankfully, you made a reservation in advance, so your table is ready for you right away. Now, you don't have to wait. or worry about someone else taking your table. Reserving a table at a busy restaurant is a lot like a virtual private cloud. A virtual private cloud, or VPC, is a private cloud hosted within a public cloud, enabling organizations to use the public cloud's resources while being completely isolated from other cloud users. So just like having your table ready at your favorite restaurant, using a VPC as a cloud security professional allows you to take advantage of public cloud resources while having your own private section. Sounds pretty ideal, right? VPCs form the backbone of a cloud provider's network and assures privacy for your cloud security team. In Google Cloud, VPCs are global resources, meaning they're not attached to any specific zone or region. The global nature of Google Cloud VPCs makes it easier to design highly available cloud environments. VPCs facilitate network segmentation, which is an architectural approach that divides a network into chunks called subnets. Segmentation is important for network security because it improves an organization's ability to closely control and monitor network traffic. Segmentation is beneficial to organizations because separating cloud resources that shouldn't communicate with each other into different subnets reduces the attack surface. Subnets also allow the cloud security team to pinpoint and isolate issues when they arise. Google Cloud VPCs offer several other security features, like firewall rules. Firewall rules determine who can access specific subnets based on IP addresses, helping enforce the principle of least privilege for employees. You can also access VPCs from other remote networks. Virtual private networks, or VPNs, facilitate encrypted connectivity between networks. In a traditional environment, employees use a VPN provided from the company's on-premises infrastructure to connect to remote assets. With a cloud VPN, you can connect from your on-premises infrastructure to the cloud. Using the cloud's infrastructure also means the VPN can be set up in minutes rather than months. Cloud VPNs have revolutionized the ability to work from home and connect to your job's resources. Imagine you've landed your first job as a cloud security professional, and you've been assigned to work remotely. Cloud VPNs allow you to access the files, folders, and documents you need using only a web browser or applications. Several CSPs offer VPC services that directly connect on-premises networks to the cloud, using network circuits for faster connection speeds. For example, Google Cloud offers Cloud Interconnect, a service that connects your organization's network to Google's virtual private cloud. This service provides users with a highly available and low-latency solution for hybrid cloud environments. Virtual private clouds are a great advantage to cloud security teams working with CSPs. As a cloud security professional, you'll benefit from your resources being globally available, all within your own private slice of the cloud. With VPCs, your data always has a reserved place at the table. Congratulations on making it to the end of Security Principles in the Cloud. Along the way, you've learned many options to secure cloud environments using security principles. First, you explored how to use security controls in cloud computing. You also learned how a defense-in-depth approach helps to secure cloud resources. Then you discovered the different security responsibilities you and the CSP share. You learned about the shared responsibility and shared fate models, and the considerations you should make when sharing security with a CSP. You then built on shared responsibility concepts while exploring different cloud service models. You also learned how infrastructure, platform, and software as a service offer varying degrees of security responsibilities. Next, you reviewed how identity and access management helps leverage control over cloud resources. You also learned about the roles that the principle of least privilege and separation of duties play in identity and access management. Last, you discovered how networking concepts translate to the cloud. You learned about software-defined networking, virtual private clouds, and load balancing. Great work on your progress so far. You're doing a fantastic job. The world of cybersecurity is a rapidly changing field where you, in a cloud security role, have to quickly adapt to new types of attackers and threats as you encounter them. With these ever-changing threats, your approach to securing your assets and information has to change accordingly. Being able to adapt and quickly react is an exciting and necessary skill to practice as a security professional. In this video, you'll be introduced to the security lifecycle and its relationship to software development. Throughout this section, you'll dive into the security lifecycle as it relates to development, security, and operations, DevSecOps. software pipelines, the software supply chain, and infrastructure and policies as code. You'll begin by learning about DevSecOps, its history, and how it has altered the workflow of professionals in development, security, and operations. Then, you'll examine software pipelines more closely and learn how you can use them to leverage automation to ensure consistency across software development processes. You'll inspect continuous integration and continuous delivery, also known as CI/CD pipelines, and the security team's role in reducing development downtime and human errors along the way. Next, you'll discover the software supply chain and the components that are critical to secure. We'll dig into artifact threats and vulnerabilities and how to mitigate them. Finally, you'll review infrastructure and policies as code, and practice applying infrastructure as code concepts in the workplace. You'll also be introduced to tools and processes that support automation in the cloud landscape. The security lifecycle is an exciting process, and we'll introduce you to lots of important strategies for following this lifecycle. Good luck!
My name is Dayo, and I'm a security engineer at Google. I work for a team called Enterprise Infrastructure Protection, and essentially what we focus on is implementing controls to enable Googlers to do their work in a secure manner. I would say my journey or my background, it's a bit non-traditional. Growing up in Nigeria and the types of courses that I took and the types of resources that we had available to us, it's not cutting edge. And what I mean by that is we didn't have adequate opportunities to resources like laptops to be able to write code efficiently, right? We'll be in class and probably have like a group of 4, 5, 6 students on one computer learning how to write code, right? It's not the best way to learn. That really challenged me in a few ways where, one, I didn't really like writing code growing up. And two, I had to seek out other means to learn what I know now. Some of the other methods that I used to learn is just picking up on random YouTube videos or picking up books that I, out of my own personal time, just put in extra hours to learn what it is I'm trying to achieve. I obtained my bachelor's degree in Nigeria in computer science. And then right after my bachelor's, I landed my first real job in the industry as a network engineer. So I did things like configuring switches and routers, going to client sites to provide internet services for them. It got to a point where I felt like I needed to push myself a bit further by education. So I migrated to the United States to do my master's degree in cybersecurity, and that's where the journey in security started. Cloud is a very exciting space to be in right now. Cloud is now the new cool, right? Pretty much a lot of our resources, be it computing, storage, other things, all live in cloud, right? So the skills that you're learning from taking the certificate is really going to be beneficial to you and the company that you end up working with. As part of my continuous learning, one thing I'm actually learning about and studying right now is I'm taking a certificate in cloud security, specifically cloud cybersecurity. It's fast growing, and cloud, especially cybersecurity in cloud, is a skill that I didn't want to get for myself. So I'm taking a certificate just like you are to arm myself with additional knowledge to be able to thrive in that space. Learning is what has brought me to where I am right now. Just looking back in my career over the years, I would say the main reason why I decided to keep pursuing my goals is through learning. I would say learning can definitely be life-changing. Look at me, I'm an example of that. I work for Google in Silicon Valley.
Imagine a situation where you spend months on a cloud security team creating an app. The team finishes developing the code and sends the app to the operations team, who release it soon after. The app is well received by its users, who highly rate its security features. This situation might appear too good to be true, but with the introduction of DevSecOps, this scenario can be a reality. DevSecOps is a culture that consists of guidelines, best practices, and tools that development, operation, and security teams use to collaborate. DevSecOps has become an integral part of the software development lifecycle. The software development lifecycle is a process for developing, testing, and monitoring software. Security was not always a key component in the framework. DevSecOps actually began as just DevOps, but security was added as a component because of several problems in the original framework. To understand how the addition of security helps to resolve problems, you'll need to know the history of the framework and its impact in the tech workspace. The term DevOps consists of two terms: Dev, which refers to the development team, and Ops, which refers to the operations team. Prior to the popularization of this framework, each team was a separate entity. The Dev team built the given application or software, and the Ops team managed the infrastructure, deployed the finished product, and monitored the release. The DevOps team would perform security checks as the final step before deployment, leaving security as an afterthought instead of an integral part of the development process. This separate workflow caused several problems. Many teams reported to different leadership, resulting in members of those teams receiving varying direction and priorities. This separation resulted in separate and even competing objectives. Additionally, these teams usually worked in isolation, with little interaction between them. The combination of conflicting priorities and sparse communication resulted in software releases that contained a lot of issues. Across the industry, people working on different teams became frustrated with the disconnected workflow. In the early 2000s, professionals from both sides took to online forums and even met in person to resolve the issues in the industry. This collaboration helped to create and bring unity to the DevOps framework. Today, communication, collaboration, and shared responsibilities are the core of DevOps culture. Across teams, every person is accountable for their contributions in the development process. Fast feedback is a cornerstone of improved communication. Receiving timely feedback allows developers to implement revisions and quickly roll out updates to users. Improved collaboration means the ops team is more involved throughout the development process, enabling them to advocate for the end user's needs earlier in the cycle. Likewise, the dev team monitors the product through its release, instead of merely passing it off to the ops and moving on to the next project. This infinity loop is commonly used to illustrate the collaboration between development and operations. There is no end to the loop. The software is continuously monitored, tested, and released. While the improved collaboration within DevOps solved several of the issues that appeared throughout the development lifecycle, there was still one important gap: security. Going back to my earlier explanation, historically, the DevOps team would perform security checks at the last software development lifecycle stage. When working with security in the DevOps framework, security checks became very frequent with every update and release. But with saving security as a final check, the process slowed down, causing bottlenecks. DevOps practitioners realized they needed a solution to make security more of a streamlined process. DevSecOps emerged as the solution, where development, operations, and security teams collaborate at the very beginning and throughout the development process. With DevSecOps, security teams implement automated security tests from the start of the project, which means the operations team releases applications even faster. DevSecOps culture also reinforces the security concept of shifting left. To shift left means security checks and practices are implemented at the beginning and throughout each phase of the software development lifecycle. Using the same infinity loop illustration, you'll notice that the addition of security to dev and ops strengthens the entire cycle. Shifting left with security involves a variety of shifting left practices that might include code analysis, change and compliance management, threat modeling, and security training. Additionally, automated security testing is conducted throughout the software development lifecycle to monitor for threats and vulnerabilities. With your current understanding of DevSecOps, you now know one of the common workflows of software development. Additionally, you can apply a security mindset to improve the process among development, operations, and security teams. Now you know how to use the framework to build an app with your cloud security team and reel in those high user ratings. The adoption of DevSecOps in the tech workspace led to drastic improvements in the software development cycle. In this video, you'll dive deeper into software pipelines and learn more about their advantages. But first, let's learn more about the limitations of one of the traditional software development frameworks, the waterfall approach. In 1970, Dr. Winston Royce coined the term waterfall methodology as a way to develop software in a step-by-step order. With this methodology, developers move from one step to the next. Returning to previous steps can cause the developer to lose their progress or require them to repeat their previous work. A development team completes the waterfall workflow in 6 main steps. The first step is to establish project requirements. The second step is to design the software. In the third step, the team develops the software. The fourth step is to test the code. The fifth step is to release the project. Lastly, the sixth step is to conduct maintenance for any issues that arise post-deployment. Although the phases are clearly defined, this approach has several drawbacks. One drawback is that if the test step finds any issues that the development team need to address, then the waterfall process comes to a stop, and other teams on the project have to revisit their step, like design and develop steps. A second drawback is that when one team is blocked from continuing their step, then the project can't move forward as planned, and the team may not complete the project on time. One common solution to the issues in waterfall development is using a software pipeline. A software pipeline is a process that uses automation and tools to facilitate movement through each phase of the software development lifecycle. Unlike traditional development, software pipelines help developers release changes quickly. Developers can modify an application's code without disturbing other parts of the project. With DevSecOps methodology, teams can apply the software pipeline and work collaboratively to build, deploy, and secure apps. Teams use continuous monitoring to alert for any anomalies that may arise in the development process. While they may vary based on the organization's needs, generally, software pipelines include automated integration and testing, code validation, and reporting measures. Automation facilitates a consistent process and enables seamless security scans, forming a reliable way to strengthen security. Unlike the traditional waterfall method, software pipelines introduce testing throughout the lifecycle, rather than testing the deliverables in one large batch at the end. An organization can include a variety of tools to use throughout the development project. These tools can be used to enable modular testing, conduct security checks, and even compile and analyze code. In this video, you learned how software pipelines redefine traditional project workflow, like waterfall development, and support DevSecOps methodology. Adopting this approach is another step towards streamlining your organization's development and operations. Do you like making things simpler? Me too. Let's explore some ways that software pipelines solve a lot of the complications that arise from a traditional software development framework. In this video, you'll be introduced to the most commonly applied pipeline methodology, the continuous integration and continuous delivery, also known as CI/CD pipeline. CI/CD pipelines are a valuable approach to automating build, validation, and deployment processes. What does CI/CD mean? Simply put, CI/CD is a process DevSecOps teams use to create software and automate updates. The first phase, CI, is where developers continuously create and update code that's uploaded into a shared repository. For example, uploading the code automatically triggers a validation process, builds an image, and then stores the code in a repository. Automation is crucial. Everything from the build process to validation tests should be automated. Validation tests that detect broken code trigger an alert that flags developers' attention immediately. The second phase, CD, actually has two meanings, the first being continuous delivery. Continuous delivery standardizes the continuous release of software builds to a staging or testing environment. Changes to code are automatically tested for bugs and merged into a repository. Like with continuous integration, automated tests validate any code or build updates. Once the build is ready for deployment, manual approval is required to push the updates to a production environment. The second meaning of CD is continuous deployment. Unlike continuous delivery, continuous deployment automatically deploys builds into a production environment in real time. Manual approval is not required for the updated software to be pushed out to end users. Continuous deployment can be thought of as an extension of continuous delivery. Although the processes are different, it's helpful to know that you might hear these terms used interchangeably. The CI/CD pipeline has 4 key stages: source, build, test, and deploy. Continuous monitoring runs throughout each stage. Let's take a look at each stage. In the source stage, developers compile their code into a shared repository. Each developer works solely on the source code in this repository to ensure consistency. The team monitors for any deviation from the source code. In the build stage, developers implement edits to the source code in the shared repository. This triggers a build. Once the build is complete, it continues to the test stage. Automated security tests check the new build's integrity. If any bugs are found in the build's code, the pipeline stops the process until developers fix the problem. Last, the software deploys to the end users within minutes. The DevSecOps team continuously monitors user feedback to quickly implement new features or improvements to the software. Why is CI/CD an invaluable approach to software development? One key benefit is that it minimizes downtime and reduces interruptions caused by human error. With automation built into the process and the application of continuous deployment, there's no additional time waiting for manager approvals. The less a development team needs to manually touch the code, the less likely it is that unintentional errors will occur. Another important benefit of using a CI/CD pipeline is that it gets updates to apps and users faster. Users don't have to wait for new releases or for bugs to be fixed. Once the developer has committed changes to the code in the repository, the update is well on its way to automated deployment. Now that you have the basics down, let's consider security's role in the CI/CD methodology. When planning your pipeline, there are certain points where you can incorporate security checks throughout the development lifecycle. Next, let's cover some example places to add security checks during the first few phases. In the source stage, the source code is scanned, which triggers a build. In the build stage, the image is scanned for vulnerabilities and checked against policies. If the build passes this step, it continues to the image repository. Once in the repository, security measures can include applying IAM permissions to access the images and incorporating regular scanning to identify vulnerabilities. The test stage detects any vulnerabilities and should trigger patching and redeployment. The image undergoes another cycle of vulnerability testing and checks the build's integrity before deployment. The image undergoes another cycle of vulnerability and integrity testing before it's released in the deploy stage. Another security measure includes only limiting service accounts access to deploy builds, rather than individual human users. Recall that a service account is a non-human identity that is typically granted to virtual machines, applications, and services. Automation is a key part to each CI/CD stage because it helps the stages work more quickly with fewer errors. In this video, we covered how to integrate security throughout the CI/CD pipeline in order to reduce downtime and use automation to reduce interruptions caused by human error. Isn't it nice when things go smoothly? Today, you'll learn how important it is for you, as a cloud security professional, to secure the software supply chain. The software supply chain includes the people, processes, and tools that play a part in software development. This includes code scripts, people, and organizations, third-party dependencies, processes, and more. The software supply chain's components each have their own security vulnerabilities and can also be attacked. This results in faulty software that can harm your organization and its users. Let's cover the different vulnerabilities of the software supply chain and how threat actors might target it. The people involved in the supply chain are one of the vulnerabilities susceptible to attacks, including developers, security analysts, management, and any person with credentials to the source code repository or system. In fact, employees can be an organization's biggest vulnerability. Other vulnerabilities in the supply chain are an organization's processes and policies. This usually happens because of inadequate system access, insecure review cycles and feedback loops, software update rollouts, and even ineffective communication and approval practices. Technology and third-party dependencies also open up your supply chain to attacks. For example, you may unknowingly use dependencies like libraries, plugins, and containers that threat actors tampered with to gain access to your data. Threat actors search for people, process, and technology vulnerabilities in underprotected networks, infrastructure, and coding practices. For example, a hacker might access a business's system to change source code and even hide malware in an app. The business may then unknowingly release the app to the public, unaware that these malicious changes have been made. Attacks can occur at any stage of the software supply chain, so measures must be taken to ensure the security of resources and data. There are several ways to secure the supply chain to harden your security. Security hardening is the process of strengthening a system to reduce its vulnerabilities and attack surface. One way to protect your supply chain is to implement regular vulnerability checks throughout the CI/CD pipeline. If detected, your organization patches the vulnerability as a measure to strengthen security. Another method is to use a software bill of materials, or SBOM, to address security measures and compliance. An SBOM is a machine-readable list of each piece of software and its components involved in the supply chain. Possessing an SBOM also demonstrates to stakeholders that your project or organization not only applies security measures, but also follows compliance guidelines. Let's examine the following scenario, where a supply chain attack had significant consequences. A software company was recently vulnerable to an attack on many of their network devices. The company was unable to complete certain review cycles and feedback loops due to a shortage of resources and time to roll out their latest software update. Then, an attacker accessed the software company's system and discovered how to manipulate network traffic and credentials for malicious intent. This example demonstrates the critical need for a cloud security team to secure the software supply chain. Using secure CI/CD pipelines, incorporating security checks, and maintaining an SBOM are all ways to strengthen your organization's security and better protect your data and your customers' data. The software supply chain includes the people, processes, and technology involved in software development. As a cloud security professional, you may take on the exciting and important role of working on securing the different components of the software supply chain. In this video, you'll learn the moves of a popular framework that cloud security teams use and organizations use to strengthen their security. This type of security framework is called SALSA, which stands for Supply Chain Levels for Software Artifacts. Just as salsa dancing can be a great way to stay fit on the dance floor, I think you'll find that the SALSA framework is a great way for a business to keep its cloud security fit as well. SALSA improves security by outlining standards and controls that enhance the integrity of artifacts. So, what is an artifact? An artifact is a digital object, like a file or image, that is used in the software development lifecycle. SALSA uses guiding principles to make security recommendations. SALSA prioritizes placing trust in build platforms and code over the individuals who have access to them. SALSA does not assume a platform implements correct security measures. Instead, it requires documentation that proves builds are securely configured. SALSA's framework revolves around 3 trust boundaries: build integrity, source integrity, and dependencies. Build integrity involves verifying the software uses the correct original dependencies. For example, developers on a cloud security team should use unmodified source code and follow the workflow prescribed in their CI/CD pipeline. Source integrity tries to ensure the source code actually reflects the developer's goals and intent, and that any code modifications are easily traced and monitored. The dependencies boundary requires that any dependencies used in an artifact are examined using security checks. Now that we've learned about SALSA's trust boundaries, let's examine the SALSA levels that work together to harden an organization's security. Organizations can use SALSA's standards and recommended technical controls to reinforce security throughout the supply chain. To achieve a higher level of security, SALSA splits the security levels into tracks. Developers on a cloud security team complete each track separate from the others, making it easier to address specific security concerns. Each level of the build track focuses on establishing provenance. Provenance is a description of the processes and tools used to build an artifact. Think of SALSA's framework structure as a pyramid. L0, or the base level, indicates the artifact does not meet SALSA requirements. As a cloud security professional, you can implement the framework starting at the bottom of the pyramid and gradually moving up to more advanced levels after you've cleared the previous level. In L1, document provenance, organizations must meet minimum requirements for documenting the artifact's provenance. This might include documenting the artifact's dependencies and detailing how it was built. With documentation standards met, advancing to L2 requires using a hosted build platform for managing builds. Finally, L3 dictates that the build platform used must provide protection against tampering with the artifact's provenance. It's important to note that implementing the levels takes time, especially since a cloud security team must meet each level's requirements before advancing to the next. Depending on the size of the organization, it can take years to achieve the top level, L3. Additionally, SALSA's framework doesn't offer security recommendations for companies that intentionally create malicious software. Further, SALSA does not assess the integrity of a developer's coding practices. Completing these boundary checks and integrating each level's best practices makes artifacts more resilient, which reduces potential attacks in the software supply chain. Along with levels and boundaries, SALSA recommends incorporating technical controls, such as version control, vulnerability scanning, build verification, deployment policies, and artifact management. You can research these on your own if you're interested in learning more. In this video, you learned some great moves to apply SALSA's framework to secure the software supply chain. You learned how implementing guidelines at each of the levels gradually secures an organization's artifacts and build processes. You also learned how trust boundaries and controls reinforce these guidelines and best practices. All these SALSA guidelines will provide a great rhythm to keep an organization's security fit and in step. Implementing infrastructure in the cloud for the first time might seem like a large task for cloud security professionals and even organizations to take on. Luckily, there's a bright side. You have a lot of different tools and strategies you can use to help mitigate this challenge. One of those tools is infrastructure as code. So what is infrastructure as code? Infrastructure as code, or IAC, is the practice of automating and managing infrastructure using reusable scripts. It's another important tool in the DevSecOps toolkit and replaces the time-consuming and expensive manual provisioning of infrastructure. IAC's automation capabilities are important in cloud computing. The increase of infrastructure components, plus the need to easily scale resources, makes automation essential. Let's examine a scenario where IAC can address a situation that might occur in traditional IT infrastructure. There is a multinational plant supplier that ships plants across the globe. As different holidays approach, their mobile app and website traffic grows. Currently, they use traditional IT infrastructure to run their website and mobile app, but their IT department struggles to keep up with the increasing demand. Because of this, employees make uncoordinated changes to the system on a case-by-case basis to keep their resources running and their customers satisfied. The company also has a business objective to cut costs to account for the slow winter season. So how can the company solve its IT infrastructure problem and meet its business objective? Well, this is where IAC can help. To adopt IAC, organizations develop a configuration file that houses the source code that is used to build their infrastructure. Using code makes it easier to manage and distribute the infrastructure. One reason is because the code is stored in a shared repository, so teammates have visibility into what changes are made. IAC supports an immutable environment. Immutable means that outdated resources are torn down and replaced with an updated version, instead of merely patching the issue. The ability to quickly release improved infrastructure keeps IT and customers happy. As a cloud security professional, you can use the primary programming model to configure IAC called declarative. Using the declarative approach, you define the system's desired state from the start, including any resources and corresponding properties you might need. IAC tools first look at the current state of the infrastructure, and then make the appropriate changes to achieve the desired state for you, keeping a list of your system's objects and making your infrastructure easier to control. Adopting IAC provides lots of benefits. One benefit is that IAC lowers costs because of decreased time, effort, and complexity of using cloud resources. IAC saves costs by freeing developer time to focus on other projects, not to mention saving money by eliminating physical hardware and the space needed to store it. Using an IAC also means IT no longer needs to manually configure their infrastructure. Removing manual configuration can help to eliminate the risk of human error. Next, IAC encourages faster and more efficient development. The dev and ops teams deploy the same infrastructure throughout the software development lifecycle. This efficiency leads into the next benefit, which highlights IAC's usefulness in the DevSecOps workflow. It accelerates the speed of delivery using automation. Automation of the same infrastructure deployment ensures the dev and ops teams collaborate on the same source code, which helps keep the CI and CD pipeline running smoothly. This automation works to reinforce security by integrating security checks earlier in the development process. Another important benefit of IAC is it reduces configuration drift. Configuration drift is when a resource's configuration has altered from its original or expected state. Typically, drift happens because of unplanned changes to the configuration code, or even with unmonitored software or hardware updates. IAC reduces configuration drift by enforcing consistency through automation and using one configuration file as the single source of truth. Lastly, IAC increases accountability. Teams that share the same repository increase visibility into changes made to the configuration code, which allows for revisions as needed. As a cloud security professional, you'll work on IAC components to provide a seamless experience. Implementing security checks at the infrastructure layer ensures provisioned resources remain safe. One method of incorporating security is to automate scanning the infrastructure regularly. These scans are important for detecting configuration drift and policy violations. There are several tools available that aid in configuration management and orchestration. IAC's ability to automate scaling and security checks and enforce version control make it an invaluable cloud computing methodology. Transitioning from manual processes to automated ones can be daunting. However, remember that bright side. You have the IAC framework available to you. It's a huge asset in a cloud security professional's toolkit. Automation is a process that is becoming more relevant to the world of cloud security. Working in the cloud involves knowing how different components are automated. As a cloud security professional, it's important for you to use those components proficiently to ensure they are fully secured. In this video, you'll explore how automation concepts are used in policy as code. In a cloud security team, you'll have lots of considerations to take into account when developing software. Following policy and compliance conditions is an important task that is easily lost in the activity of building new applications. Traditionally, the cloud security team creates policies in environments where version control isn't possible. And without automation, testing policies uses up a lot of time and effort. Also, problems happen when organizations don't have a unified approach to implementing compliance security checks. These problems can include inconsistent scanning and manual application of security practices. To help prevent these problems, a security team implements policy as code. Policy as code, also known as PAC, is the use of code to define, manage, and automate policies, rules, and conditions using a high-level programming language. PAC enables developers to provision and manage their policies to meet organizational requirements. PAC also enforces best practices for compliance management. An advantage to using PAC is strengthening the security in the DevSecOps lifecycle. Automated vulnerability scanning provides developers with continuous feedback about security concerns and red flags that may lead to compliance errors. The security team can also code triggers that alert developers to take immediate action on incoming threats. The security team can automate these triggers, which removes the manual decisions of what policy to test and when to test that policy's integrity. Consider this example. You're designing an app for users in the United States that tracks the user's heartbeat. Users can choose to have the app send this data directly to their healthcare provider. Since the app interacts with sensitive health information, you must enforce policies that follow HIPAA guidelines. You choose to code these policies to determine misconfigurations, identify vulnerabilities, and automate versioning. Shortly after your team creates the triggers, you're notified of a security vulnerability and policy violation. This allows your team to take appropriate steps to resolve the issue. Now you're able to better maintain user security as they monitor their heartbeat. Your app also maintains necessary HIPAA compliance. Security is an important aspect of PAC, but there are a lot more advantages to code policies and rules. Organizations that adopt PAC enjoy several benefits. Earlier, you learned the ability to achieve version control is advantageous. First, developers can easily track code updates. And second, they can roll back revisions when needed. A third version control benefit is to improve visibility. With version control in place, project stakeholders can monitor the policy's progression and ensure that policies are appropriately incorporated. A fourth important benefit is to increase efficiency. Automating testing and removing manual policy enforcement enables developers to quickly share and scale coded policies. With greater efficiency comes the fifth benefit, which is to facilitate collaboration. Access to the shared policies as code encourages and simplifies collaboration amongst the engineering team and beyond. Centralizing rules and policies allows stakeholders to work seamlessly together. You've gained a deeper understanding of how impactful coded and automated policies can be. You also explored how PAC practices provide security to developers and end users. So take a deep breath and rest assured, you know how to use PAC in your next role in cloud security and keep the business fully secured. Security plays a very important role in the automation of software releases, infrastructure, and policy. This video introduces a new framework known as GitOps. GitOps is a framework that applies version control, collaboration, compliance, and CI/CD best practices to automate cloud infrastructure. GitOps uses Git, an open-source version control system to store configuration files. The first component of GitOps is that it uses infrastructure as code, or IAC, as a core process for automation. Developers store the infrastructure as source code in a Git repository. This repository serves as the single source of truth for all configuration files. This gives all involved stakeholders improved version control. In Git, the original source code is called the main branch, also known as the trunk branch. Think of a tree. As a cloud security professional, when you need to update the IAC, you make a pull or merge request. When you make a pull request, you're incorporating the committed files from a branch into the main trunk. Initiating a pull request includes a description of the request, details about the CI/CD pipeline, comments about the code, and the intended commits. A commit is the specific change made to a file. GitOps relies on CI/CD methodology to deliver the code commits. GitOps uses continuous integration as a method for submitting pull requests. Continuous delivery integrates security and IAC requirements throughout the software development process. GitOps supports the DevSecOps security mindset of shifting left. Cloud security analysts can incorporate security best practices like vulnerability scanning and IAC compliance checks from the beginning of development and throughout the CI/CD pipeline. There are several GitOps benefits. The first benefit is that GitOps improves efficiency and visibility throughout development. This benefit comes about when an organization can use a single tool to manage infrastructure and the application development lifecycle. Both infrastructure and application management are rooted in the same version control system. A second benefit is that this central management of application and infrastructure allows developers to easily manage services like container instances, microservices, and other infrastructure parts. GitOps principles make it an ideal model for organizations using container services. You learned how GitOps is a valuable tool for automation, version control, and configuration management. Recall how GitOps works like a tree, where you can create branches from the trunk to help streamline operations. This understanding of GitOps will help prepare you for the varied methodologies you'll encounter and use as a cloud security professional. You've come to the end of the security lifecycle. Throughout your journey, you've learned lots of concepts related to the influence of security and automation in the software development lifecycle. Great work! Along the way, you've learned how important it is to follow the security lifecycle as it relates to development, security, and operations. DevSecOps. Software pipelines, the software supply chain, and infrastructure and policies as code. You started this course with an introduction to DevSecOps and how it transforms collaboration, communication, and security in the software development environment. Then, you learned about software pipelines and the role security plays in streamlining workflow. You were also introduced to security best practices when working with software pipelines. Next, you explored the software supply chain and its components. You learn about the possible vulnerabilities throughout the supply chain and how to develop strong security that mitigates threats. Lastly, you reviewed infrastructure and policies as code and practiced applying infrastructure as code concepts in the workplace. You were also introduced to tools and processes that support automation in the cloud landscape. Congratulations on your progress so far. Keep going on your journey into the fascinating world of cloud security. Hi there, and welcome. I'm excited to explore the role of a cloud security analyst with you. Throughout your learning journey, you'll learn about the role, responsibilities, and skills of a cloud security analyst. First, you'll explore the analyst's role. Then you'll learn about different career paths and several job titles you'll encounter in your job search. Next, you'll receive an overview of the typical responsibilities of a cloud security analyst. You'll also review the wide range of exciting tasks analysts take on to defend their organization against cyber threats. Then you'll discover what it's like to be a part of the cloud security ecosystem. You'll also learn what it's like to work with different teams, communicate with stakeholders, and apply specific skills. Finally, you'll explore the different tools analysts use and get practical experience with one of Google's tools, Cloud Shell. You'll also learn how these tools are applied in the security industry. When you're ready, let's get started. Now is the perfect time to develop security skills. Cloud security is a growing field with a wide variety of exciting jobs opening up every day in almost every industry. In this video, you'll learn about some of the career paths you can pursue as a cloud security analyst. First, let's explore some of the fields a cloud security analyst can work in. The first field is information risk management, which is the process of identifying, assessing, and minimizing potential threats to information assets. Information risk management has a lot of career options for security analysts. It's used to develop strategies for securing cloud assets. Since an organization's cloud environment may include thousands of assets, it's important for risk managers to understand what their organization's environment includes, such as by using cloud asset inventory software. This allows them to conduct research into potential threats and put controls in place to make risks less likely. Information risk management could also be used to plan an organization's security budget. Each organization has a limited amount of resources to spend on security. Information risk management plays an important role in prioritizing which tools an organization spends its money on, and which assets the organization focuses on protecting. The higher value an asset has to the organization, the more money they should invest to protect it. Another field cloud security analysts can work in is cloud security posture management, or the process of monitoring and configuring cloud assets for security and compliance with best practices, regulations, and organization policy. Analysts use cloud security posture management tools, like Google Cloud Security Command Center, as centralized places to find and analyze information about what's going on in the cloud environment. Posture management involves using tooling to monitor cloud environments for misconfigurations and vulnerabilities. Using posture management strategies, cloud security analysts can also take steps to improve their organization's security posture. You might be wondering, what is security posture? Security posture is an organization's ability to manage its defense of critical assets and data and react to change. So, security posture management strategies often include regularly reviewing and updating security policies, ensuring that identity and access management services, or IAM policies, are configured correctly, and implementing and testing security controls. Cloud security analysts also review their organization's security posture regularly with cloud service providers to make sure technology features are up to date. Analysts document these reviews and use them to improve their cloud assets' security over time. As part of security posture management, analysts also communicate with non-technical audiences, including management and users. It's important for analysts to have great communication skills, so they can explain technical concepts to those who may not have a technical background. Analysts are often responsible for educating their colleagues about security best practices. A third field cloud security analysts can work in is threat intelligence. Threat intelligence includes the collection, analysis, and evaluation of cyber threat information. Cyber threats include the techniques malicious actors use to damage cloud resources or gain unauthorized access to data. Several cybersecurity organizations around the world work together to document and categorize cyber threats. The information these organizations collect include details about known attack groups, the methods they use, which systems are vulnerable, and how to reduce the risk of being affected. Cloud security analysts use threat intelligence to stay ahead of potential attackers. By knowing which assets are most vulnerable to attacks, analysts can help direct resources and budget toward the areas that need it most. Threat intelligence also helps analysts respond to incidents. When a cyber attack, breach, or other incident occurs, cloud security analysts are responsible for minimizing the impact on the organization and supporting the recovery process. Now you know about some of the different specializations available to cloud security analysts. Consider your own interests and start to think about whether any of these might be a good fit for you. In this video, we'll explore some of the common responsibilities cloud security analysts may have in their role. This is a great opportunity to think about what aspects of cloud security are interesting to you. First, it's important that cloud security analysts are familiar with the core products that cloud service providers offer, including computing, storage, and networking. These products help analysts manage their responsibilities and complete the tasks they need for their roles. One of the many responsibilities cloud security analysts have is mapping security concepts to cloud products. Mapping allows analysts to identify potential attack vectors for their organization's cloud assets. By anticipating how attackers might try to harm the organization's assets, analysts can focus on strengthening the defenses that need it most. Analysts are also responsible for using tools to check for vulnerabilities in virtual machines, containers, and networks in the cloud. Cloud security analysts use these tools to track their organization's assets and check for misconfigured settings or other conditions that could make an attack more likely. Cloud security analysts also use tools to analyze threat detection and security compliance reports. Depending on the industry, an organization's cloud environment may be required to follow specific security standards or regulations. So, analysts are responsible for using cloud tools to maintain compliance and gather information about potential threats. Another responsibility cloud security analysts might have is communicating with their organization about the security of their cloud environment. To do this, analysts use information from cloud monitoring tools to prepare status reports for management and other security team members. Threat detection and analyzing compliance reports are just a few of the ways that security analysts monitor their organization's infrastructure for potential security incidents. For example, analysts use cloud logging tools to collect information about user actions, system activities, errors, and other security-related information. Analysts are also responsible for identifying unusual activity involving the organization's network, virtual machines, or containers. Another responsibility of cloud security analysts is responding to security incidents, like a malware infection or an attempt to gain unauthorized access to cloud storage. Responding to a security incident starts with identifying unusual behavior and determining whether it's an actual threat or just a false positive. If it's a threat, analysts work to contain it. This could include shutting down a virtual machine running harmful software. After an incident, analysts help the organization recover. Then, they document what went wrong, so the organization can be better prepared in the future. To continuously improve their organization's security posture, cloud security analysts are responsible for testing and evaluating new security products. This could include deciding which security products their organization chooses to use, and how those products are configured. Additionally, analysts regularly test security products to make sure they work properly. Finally, cloud security analysts are responsible for staying up to date with the security and technology industries. By understanding new cloud technologies, analysts can learn to secure them. Like new technologies, new cyber threats are always emerging and evolving. So cybersecurity organizations and cloud service providers use threat intelligence to document and share information about these threats. Several organizations also post blogs and reports that cloud security analysts can read to stay up to date on the latest developments. Now that you've got a better idea of what cloud security analysts do every day, you're even closer to finding the role that's right for you. Ready to learn about your future coworkers? Cloud security professionals have a lot of responsibility, but they don't do everything alone. In this video, we'll explore the wider cloud cybersecurity ecosystem and discuss some of the potential teammates you may work closely with as a cloud security professional. Let's get started. What is a cloud cybersecurity ecosystem? The cloud cybersecurity ecosystem includes the network of people, processes, and technologies that work together to keep the cloud secure. The cybersecurity ecosystem includes everyone, from large organizations to individual users. If you end up in a cloud security analyst role, you'll most likely be a part of your organization's Security Operations Center, or SOC, which detects and responds to cybersecurity incidents affecting the organization. Some of the professionals you may work with on a cloud security team include cloud security architects and cloud security engineers. You may also work with compliance team members. Let's learn more about each of those roles. A cloud security architect is a professional who designs and develops security controls and measures within an organization's cloud infrastructure. Cloud security architects develop these controls to ensure the confidentiality, integrity, and availability of their organization's information. They also consider the organization's specific goals and security requirements. A cloud security engineer is a professional who implements and manages secure cloud workloads and infrastructure. Cloud security engineers also configure access to cloud resources and put security controls in place to protect data and workloads. They support compliance with security best practices, regulations, and standards, and manage operations within the cloud environment. The compliance team is a team within an organization that ensures processes act in accordance with laws, regulations, and standards. Depending on the industry and location, one or more laws apply to most organizations storing customer data in the cloud. Security teams also work with compliance departments to make sure cloud assets align with legal requirements. In this video, you learned more about the cloud cybersecurity ecosystem and some of the professionals you may be working with. Working in such a vast space means collaborating and communicating with others to achieve success, which can be a very rewarding process. As a cloud security professional, you'll frequently be in charge of conveying important information to people who need it. These people, usually referred to as stakeholders, will need you to keep them updated. In this video, we'll discuss working with stakeholders as a cloud security professional. A stakeholder is a person or organization who can affect or be affected by a system. Stakeholders of an organization's cloud environment include anyone who might be affected by whether or not the cloud remains secure. For example, management and leadership, other departments, and end users of products can be stakeholders. Because cloud professionals help to create their organization's security policies, they also educate non-technical staff on how to keep cloud assets secure. So, cloud security professionals often need to discuss cloud security concepts with stakeholders. If a security incident, like an attack or data breach happens, cloud security professionals may meet with leadership to explain the situation. They may also be involved in planning communication with users affected by an incident. Let's discuss some of the skills you'll need to communicate with stakeholders. As a cloud security professional, it's important to keep your technical communication skills current. You'll use these skills to communicate effectively with other security team members, as well as with stakeholders. Because you might sit in on meetings, discussions, and information gathering sessions with stakeholders, it's a good idea to hone your note-taking and listening skills, so you can capture details, requirements, and action items. Taking notes and listening will help you to gather accurate information, interpret security requirements, and accurately address stakeholders' concerns. Security professionals are also skilled in balancing the needs of different stakeholders. It's common for different departments within an organization to have diverse needs for cloud security. For example, the compliance department is more focused on having the legally required controls in place, whereas the product department is more focused on ease of use. Communicating with stakeholders is one of the most exciting parts of a cloud security analyst's job. You're that much closer to improving your communication skills, which will help you keep the cloud even more secure. Cloud security analysts have a lot of important responsibilities and usually work with a variety of people inside and outside of their organizations. To be successful in their role, there are many skills they'll need to develop. Learning these skills is like adding tools to a tool belt. The more tools you have, the more situations you'll be prepared to handle with ease. In this video, we'll explore cloud security analysts' role within the security ecosystem and within their specific organization. We'll also cover the skills you'll use to succeed in your responsibilities as a cloud security analyst. Let's review some of cloud security analysts' responsibilities within the security ecosystem. As a cloud security analyst, communicating cloud security concepts to a non-technical audience is a core responsibility. For example, you might help to train other departments in using the company's IT assets securely. As a cloud security analyst, you may also work with compliance teams to help develop cloud security policies for your organization. To do this, you'll need to understand and communicate industry security compliance standards to help make sure the organization aligns with all the laws and regulations that apply. By keeping your organization's cloud assets safe and in compliance, you'll help keep the cloud safer for everyone. Next, let's discuss some of the core skills you'll need in your role. Developing problem-solving and analytical thinking skills will be important to your work as a cloud security analyst. Issues can come up suddenly, so you and your team will need to work quickly to resolve them. Even if you're working on a new type of issue, being able to break it down into smaller parts makes it easier to understand the problem. This will help you identify the best solution. Being able to do this in different situations is a valuable skill that will serve you throughout your career. Attention to detail is an important skill for a cloud security analyst to have. The difference between normal and abnormal activity in cloud resources can be subtle. Cloud security analysts who pick up on details can catch and solve problems before they grow into serious issues. And that's a huge help to any organization. As a cloud security analyst, you'll be an important part of the cloud security team. You'll also work with other departments as needed. Because you'll be working with others, Collaboration is an important skill you'll need to be successful in your role. Next, let's explore some of the technical skills cloud security analysts use on the job. As a cloud security analyst, you'll learn to define and configure security controls. Security controls are controls that safeguard cloud environments from threats and minimize the effects of harmful attacks. Security controls include antivirus software and firewalls. Another major part of a cloud security analyst's role is to conduct network analysis. Analysts configure and use security tools to closely monitor and log network activity in the cloud, then receive alerts when something appears out of place. Security analysts also use their skills to monitor and manage intrusion detection systems, or IDS, and intrusion protection systems, or IPS. Intrusion detection systems monitor your cloud system for threat actors trying to gain access, while intrusion protection systems proactively remove threats based on specific rules. Depending on the industry, an organization's cloud system may be audited for compliance or security by internal auditing teams or external regulatory bodies. Cloud security analysts prepare for audits by understanding the audit requirements, identifying weaknesses, and implementing necessary solutions. After an audit, they collaborate with audit teams to plan for improvement. As a cloud security analyst, there will be many opportunities to learn new skills and develop those you already have. And as you develop these skills, you'll be better prepared to handle the responsibilities that come with your role. There's no better feeling than knowing exactly what to do when a complex security problem arises. Cloud cybersecurity is a fast-paced, exciting field to work in. Cloud security professionals are always working to defend organizations from cyber attacks, and they get to use a variety of tools to help combat these threats. The amount of tools available to cloud security professionals continues to grow. In this video, we'll examine a variety of tools, including Linux, Terraform, reCAPTCHA, Wireshark, VirusTotal, and LucidChart. First, let's discuss Linux. Linux is a widely used open-source operating system. Linux uses a shell environment as the command line interpreter. The shell translates your commands so the computer can perform the instructed task. Lots of security tools run on Linux, so it's helpful for you to gain practical experience using it, so you can install and run these tools when needed. With Linux, you can verify the status of each application in your infrastructure, review networking traffic, and filter access to non-production IPs and ports. Next is Terraform. Terraform is commonly used in cloud security as an infrastructure as code tool. Terraform enables you to automate the provisioning of cloud resources. Security teams can use Terraform to consistently create health checks and security enforcement policies across their infrastructure. Using Terraform, you can create templates that are pre-approved and checked by the security team, so the engineers building infrastructure can repeat the same pattern safely every time they create new assets. Next is reCAPTCHA, a risk analysis engine that detects and helps prevent spam and malicious behavior from happening on websites. For example, imagine you manage an online store that lists customer reviews and comments for each product. reCAPTCHA scans the reviews to identify any reviews made by a bot, alerting you to questionable traffic. reCAPTCHA also helps prevent bots from spreading malicious information about your services or products. Additionally, this tool is capable of filtering spam and even detecting fake friend requests on social media. Then there's Wireshark. Wireshark is a packet analyzing tool that provides insight into your network. This insight allows you to quickly identify the root cause of issues and enables you to focus your investigation. With Wireshark, you can apply different kinds of filters to packet captures to identify suspicious activity, like data exfiltration. This capability makes Wireshark a valuable tool for cloud security analysts. You can also use Wireshark in a specific interface and review all traffic passing through. This way, you recognize and separate normal packets from those that are a possible risk, then act to protect the infrastructure accordingly. Another important tool is VirusTotal. VirusTotal is a website that analyzes files and URLs for malicious content like viruses, worms, trojans, and more. Data retrieved from these websites is shared with the greater security community. Security professionals use VirusTotal as an investigative tool. For example, a security analyst might use VirusTotal to scan their organization's email messages for suspicious attachments. Next, Lucidchart is a diagramming application that helps users communicate and collaborate across teams. Cloud security analysts use this tool to help document security processes using visuals. It can also be used to map out networks and data flow. Security teams also use Lucidchart to help meet business requirements. For example, it's common to create diagrams that show how information flows through a system, so that you can identify and implement the appropriate protection measures. The security team can leverage Lucidchart's diagramming features to set goals, meet requirements, and add milestones along the way. In this video, you explored various tools that cloud security professionals frequently use in the workplace. Using a combination of these tools can help strengthen your security posture and defend against cyber threats. When you use a cloud service provider, you can access your cloud resources in several different ways. You can use the provider's console or a command line interface, also known as a CLI, from within the console. In this video, we'll explore Google's Cloud Shell, an easily accessed CLI where you interact with your cloud environment. Cloud Shell offers you the ability to manage cloud resources with the command line. It provides a convenient way to enter commands or develop shell scripts that perform tasks in a user's cloud environment. Cloud Shell's environment is provided at no cost, but the shell itself is temporary and will shut down after a period of inactivity. After the shell is shut down, you won't be able to execute production actions or leave production files in the operative system disks. Cloud Shell is accessible through a web browser, so you can use it anywhere at any time. Utilities like tools and commands are pre-installed, so you can easily start experimenting with and managing your resources right away. Cloud Shell uses the Google Cloud CLI, also called the G-Cloud CLI, to build and manage resources. The G-Cloud CLI includes a suite of G-Cloud commands that perform tasks. These commands are nested into command groups that represent different Google products. For example, imagine you want to create a virtual machine on Google Cloud. To do this, you would use the product compute engine. The command group compute can be used in Cloud Shell to initiate the creation or manipulation of Google Cloud Compute Engine resources, like virtual machines. You can also use Cloud Shell to perform a variety of tasks. For example, you can develop and deploy applications. You can even create storage buckets, access databases, and view and edit files. You can also execute Terraform infrastructure as code scripts to build a test, QA, or production environment. As a cloud security analyst, you might use the Cloud Shell to create VPCs, or virtual private clouds, and view your networks in any given region. Remember, VPCs provide network capabilities to resources like virtual machines or containers. Let's explore how to create a VPC and subnet using Cloud Shell. First, go to cloud.google.com/cloud-console. Then, click the Activate Cloud Shell button in the top right corner of the page. The shell will open in a terminal window right on the web page. The first step to creating a VPC is to enter the following command: gcloud compute networks create labnet --subnet -mode equals custom. Let's examine each command. Gcloud invokes the Gcloud command line tool. Compute is part of a group command that allows you to create or manipulate compute engine resources. Networks is a subset of the compute command that specifies the compute engine network. Create is the action you're instructing the group to execute. And labnet is the name of the network you're creating. Next, you can create a custom subnet. Subnets in a given region must have unique names. Let's name it labnet-sub. The full command is gcloud compute networks subnets create labnet-sub --network equals labnet space /. Press enter. Then --range equals 10.10.0.0/28 space /. Press enter. Then --region equals US-east 1. This command lists the region and IP range for your Cloud Shell session. Now let's view the networks we just created. We'll run gcloud compute networks list. Here, there are two networks listed. The network named default was created when the project was initiated. You can delete default networks for security purposes. The network named LabNet was created by the gcloud command you entered earlier. Last, you can verify the subnets using the following command: gcloud compute networks subnets list -- network equals LabNet. The LabNet subnet appears, confirming the VPC network was successfully created. Wow, you just explored how to create a VPC and subnet using Cloud Shell. That was a lot of information. If it felt like a challenge, that's okay. Working in this type of environment will get easier with time and practice. And I'll be here to encourage you along the way. Remember, Cloud Shell has many capabilities and is a valuable tool to develop your resources from anywhere, anytime. Congratulations on completing the introduction to cloud computing. You started by learning all about the cloud and its underlying infrastructure. You also learned about components of cloud computing like virtualization, containers, and storage. Then you explored security in the cloud and learned about security controls, shared responsibilities, identity and access management, and networking concepts in cloud computing. Next, you explored the security lifecycle and how it relates to DevSecOps, software pipelines, the software supply chain, and infrastructure and policies as code. Finally, you learned about the cloud security analyst's role and the responsibilities and skills common in the field. You also reviewed many of the tools analysts use on the job. You've started to build a foundation of cloud security principles that you can continue to expand on in your future career as a cloud security analyst. Coming up, you have even more exciting discoveries to make. Get ready to continue on your cloud journey.
My name's Chris. I am a staffing lead working in people operations at Google. I'm essentially trying to make sure that we are helping to staff those organizations and helping to guide business strategy to ensure that we're hiring with an inclusive and a diverse lens. I've been in recruiting for about 17 years, 18 years. So yeah, it's been a lot of resumes. Personal branding is huge. It is, in a lot of ways, the new resume. One of the big ways to discover your personal brand or enhance your personal brand is to kind of surround yourself with like-minded individuals or individuals that are interested in the roles that you're ultimately trying to pursue. So joining groups of folks that might be involved in cybersecurity, if you're going for that type of a role specifically, they will help you not only keep up to breast with the most detailed information in the news, the new articles, the new releases, keep you current with those types of things. And technology moves very, very quickly. So it is good to have people around you that can kind of keep you up to speed there. Reaching out for coffee is an excellent way to get to know someone, get to know their environment, and honestly, to get to know nowadays a little bit about the work-life balance that's going on in the environment as well. Some do's when you're interviewing. Feel comfortable understanding the question, which means please feel comfortable asking qualifying or clarifying questions. Repeat and re-articulate that question to make sure that you're actually answering the thing that was asked of you. And at the end of it, ask if that answers the question to make sure that you've actually articulated your point clearly. So that would be the first thing. One other thing that I would definitely make sure that you're doing in the interview is don't feel afraid to ask questions of your interviewer as well. You can ask multiple questions. Don't feel like they always have to be asking you things, but things like, what's the environment like? What's the work-life balance like? If they're comfortable sharing it with you, hey, what's one of the big challenges that your team is working on right now? So that you can understand if some of those challenges are similar to some of the challenges that you're dealing with, and that can increase your confidence level, right? You know that, I know how to deal with this type of a thing. There is an element of learning what your worth is in the market, and sometimes that can take a little bit of time. It's very important to apply often and feel comfortable with potential rejection. You're frankly not going to get the interview request at every company that you apply to. You're definitely not going to get the offer from every company that you interview with. And you should go into it understanding that. This is going to be a journey where you're going to be exploring things that you're interested in and things that will hopefully lead you down the path of your next career. I always encourage candidates to celebrate after getting a role. You are probably unaware how much pressure you're putting on yourself during the interview process. Really acknowledging that and taking the time and taking that beat to sit with that for a moment is important before you take that next step. When I got this job, I went out for a crab boil. I remember I came off of the plane, and I was getting some good news. I was taking a trip somewhere, and we landed, and there was a crab place right there, and we sat down and got some crabs. So loved it. Hi, I'm Chris.
Hi, I'm Kevin.
And congratulations on making it through this course. Now we're going to give you a little bit of a sneak peek on what you can expect for an interview that will cover some of the questions from this course.
We hope this will help you know what to expect in your next interview.
All right, Kevin. So first question for you. What interests you in a career in cloud security?
Chris, my interest in cloud security really comes down to how pervasive cloud security is in our day-to-day lives. Everything from streaming movies and video games pretty much runs on the cloud these days. It's how technology is evolving to become more efficient and accessible and equitable for people around the world. With it becoming more accessible and services running on it, such as banking and family photos and so forth, protecting that information is paramount. So my interest in security for the cloud really comes down to making sure that all that information stays protected and safe.
Well, imagine you would need to explain the main differences between on-premise and cloud computing to a business leader. How would you go about it?
If I was talking to a business leader and trying to describe the differences between on-premise computing and cloud computing, first, I would try to understand how much they understand about cloud computing and on-premise computing. How technical is this business leader? Have they worked in IT, or have they worked, from more of a business perspective where they sort of learned how businesses operate? Or have they actually worked in a server room where they actually built data centers and built servers and deployed computer racks? And depending on where their technical foundation lay, then I would talk to them about how really the biggest differences are with cloud computing. You can save costs and share responsibilities with a cloud provider. So with on-premise computing, they need to hire specialized staff, educate that staff, help them with on-the-job training and possibly cross-training. But with cloud computing, they can rely on a third party that will offload most of those responsibilities for them and help them just run the business.
Imagine a scenario, right, where you're asked to implement infrastructure for a project. What are the benefits of using infrastructure as code in this type of a situation?
When asked to implement infrastructure as a code, really just it's more efficient. It works in ways that can be automated. So there are various vendors and various products that allow you to write what we call playbooks in a human-readable fashion. Think of it as a recipe. Right? Think of it as a recipe book, and you can sort of have this recipe book that you can pass on to people who are working in the kitchen, and they will all follow this recipe and do everything exactly as it is. This is really what helps cloud computing become efficient, because if you as a client start with a small business, let's say you have 3 employees, and you'd like to provide them something as simple as email service. What you might do traditionally is maybe deploy that on their individual laptops and go in there and configure them and modify different parameters and do this for each person. And in a small business, that's maybe can be done pretty quickly. But your business starts to grow to 50 employees or 100 employees or 1,000 employees, or big companies like Google, you have 400,000 employees across the world. You can't go to each person's computer and start modifying these settings and parameters. So what you do is you deploy infrastructure as code, and you write these playbooks where you send rules to all these computers, and they automatically build out and deploy everything the same way across the world.
All right, well, how would using a cloud shell support you in your role as an entry-level cloud security analyst?
Cloud Shell would support my role as a entry-level cloud security analyst by giving me access to generally what we would define as a shell-like or terminal shell-like virtual machine interface. that allows me to interact with the cloud environment. This could be something like an integrated development environment, an IDE, where I can run and execute code. And the beauty of an IDE is it'll allow me to have things like color coding of various aspects of the code. Functions will be highlighted one color, various variables will be highlighted different colors. And it really enables sort of this automation and ease of access and modifying of system files and cloud parameters through a shell-like environment.
So what is cloud firewall? What should a cloud cybersecurity analyst consider when defining firewall rules on Google Cloud?
A cloud firewall can be an application or hardware, and it's essentially a resource that allows you to control traffic that comes in and out of a cloud environment. It can allow you to create firewall rules. You can do things like filter out or block port 22 if you don't want SSH access into the cloud environment. It also allows you to sort of create rules that you can distribute to many different computers or many different services running on a cloud platform. Earlier, we alluded to sort of infrastructure as code and the ease by which you can deploy playbooks and rules as opposed to doing them manually at each endpoint. Well, with a cloud firewall, you can automate these tasks. You can make them all in a central resource, and then you can distribute them to remote resources.
Thank you.
Thank you for having me.
In this scenario, Kevin was able to demonstrate how to talk through his answers to show his thinking. By sharing your thought process, you're able to demonstrate what you know and how you solve problems. Problem solving is one of the main things that hiring managers are going to be looking for in an interview. Well, that's it for now. Stay tuned for some more interview tips.
Congratulations on finishing this course. You are well on your way to accomplishing great things in cloud cybersecurity. I love working in an industry where I can protect millions of users every day. We work behind the scenes to improve lives, and soon you will too. Let's take a minute to go over all the things you learned in this course. You began by exploring an introduction to the program and tips for successfully completing the certificate. You also learned about cloud computing and cloud infrastructure, plus how virtualization, containers, and storage function in cloud computing. Next, you deepened your defenses in the cloud using security controls, identity and access management, and networking practices. You also discovered how users and cloud service providers share security responsibilities in different cloud models, like infrastructure, software, and platform as a service. Then you explored automation in the security lifecycle. You learned about teams and workflows, along with automation's role in software pipelines and infrastructure as code. Plus, you learned about the software supply chain and the importance of securing it. Finally, you explored the roles, responsibilities, skills, and tools of a cloud cybersecurity analyst. You experienced Google's Cloud Shell and added some useful solutions to your cloud security toolbox. Congratulations on your progress so far. You're off to a great start.